Good morning and good evening. I'm your Kafka instructor. My name is Arith. I welcome you all to Apache Kafka certification course. I hope I am audible to all of you. Please respond if I'm audible. You may use the question and answer window and please respond. Thank you, Pirish. Thank you, Shravan. Thank you, Bhaskar. Thank you, Ajay. Thank you, we both. Ravi is asking, I think this is the first class today. Yes, Ravi, that's right. So, how about others? I only got confirmation from Ravi, Purush, Shravan, Bhaskara, Ajay, we both. So how about others? Muhammad Nazim, am I audible to you? And Neelam, am I audible to you? Muhammad Nazim and Neelam, please respond if I'm audible to you. No response from them. Let me just send a message to them, to both of them. All right, I just sent the messages, but no response yet from both of them. Mm, most probably Muhammad Nazim and Neelam. If I'm audible, please respond. All right. So please use the now I have sent a message using the private messaging system. So you would be please put your questions or anything if you want to communicate with me. Use the question and answer window. All right. Fine. Thank you. So don't use the window which I used now. That's for private to private message. All right, all right, fine. That's fine, Muhammad Nazim. He just joined now, it seems. Fine. So now I think I'm audible to all of you. That's great. So please read these instructions. It's very important. So by default, all of you on mute, right? The reason why we keep all of you on mute is like there would be a lot of background noise if I keep everyone on unmute, right? So by default, everybody on mute. Whenever you have any questions or any doubts, you can please use the question and answer window and you can ask. Or else, if you feel like you want to ask me directly, you can just use the question and answer window to unmute you, right? Then I will unmute you and then you will be able to speak. So everyone else can listen that as well. All right, so whatever questions you post, I'm the only one who will be able to see the question. So whenever someone posts a question, I will read out the question for everyone else and then I would be answering it. All right, and I want to make the session as interactive as possible. because this being an online platform, I won't be able to see your faces, and I won't be able to make out how much you have understood and how much you have not understood, right? So please ask questions. Let it be any silly questions, let it be any complicated questions, whatever, whatever confusion you have in your mind, please ask that. So I'm ready to help you the way how I can. So don't worry about it. So it'll be any simple question. So someone else also might be having the same kind of questions, right? So please ask your question, whatever comes to your mind. The only point here is like we have to learn Kafka end of the session, right? End of the day, end of the course, right? So please ask your question, whatever comes to your mind. So you can treat me as your colleague or friend or whatever, right? So you can please ask me any question that comes to your mind. All right. So at times what happens is like, maybe I'm not audible, or like, maybe I'm audible to everyone else except you. So in such cases, like, just a relogin would most probably, most of the time, the relogin would or rejoining would fix the problem. So in case if I have any problem, so I will again come back within few minutes. All right. So you can be in the session, I will rejoin. So if at all I'm not audible to you and all, please try to rejoin. Most of the time it fixes the problem. All right. And try to be on time. So today we have about 8 participants. That is Ajay Mitapalli, Bhaskar Rao, Muhammad Nazim, Neelam Maurya, Purush Ranga, Ravi K Ashtukar, I'm sorry if I'm pronouncing it wrongly, and Shravan and Vibodh Finani, right? I hope I'm audible to all of you, right? Okay, fine, fine. So before we start, do you have any questions to me? Okay, looks like no questions. So before I start, I'll give you a brief intro about myself. So as I told you, my name is Arith. I work for a product-based company based out in Bangalore, and the domain which I work is called ABL or APM. ABL is relatively a new domain. It's called application behavioral learning, or in a easier way, it is application performance monitoring. So I work in a space where we monitor external application and collect some of its like, it its health data, and we analyze that, and accordingly we would be able to predict its like if any kind of issue which might happen in the near future, we will be able to predict that. That's a whole idea about the product. So we use technologies like Apache Flink, it's a distributed computing technology, and Kafka as a messaging systems, and Cassandra as a storage, and various other technologies as well. Okay, so Muhammad Nazim was asking, he just wanted to know how detailed we go in Kafka. So we have 10 modules, and each module has one topic. So the first 3 modules is we cover we cover very deeply about Kafka producers, consumers, and also I would say yes, we are actually covering a lot in Kafka here, right? For the developer point of view, whatever you should know, that we are covering here. In fact, some extra information is also is covering. I feel those informations are not really necessary, but still that has been also been covered here. All right, Nazim. All right, so Ajay Mitapalli is asking, if we miss any classes, we are provided access to the recording of the class. Okay. uh, Yes, so every class is getting recorded, including your questions, answers, whatever you ask and whatever I say, right? Everything is getting recorded. So if you go to the corresponding module, right? In that module, you would be able to get the recording. So the recording would be usually would be available to you within 2 to 3 hours of time. right? After 2 to 3 hours of the class, the recording will be available. So anytime you will be able to access this, and the lifetime you will be able to access those recordings. All right, Ajay. So Vibod is asking, will there be any hands-on project towards the end? Yes, we do have a project in the end. So I'll be explaining the scenario, and then I'll be also giving you the solutions. After that, you have a project which you will have to do yourself. Even that is a part of your certification, right? Like that is also there in the towards the end. Yeah, so Purush is saying he will not be able to attend tomorrow's class. I will check the recordings. Thank you for updating, Purush. Yes, you can do that. And I would say please not miss any of the beginning classes. I mean, even if you miss it, please go through. It's very important. The first three modules, right? That is the core part of Kafka. And in fact, I'll be taking more time to explain you the first three classes, right? So please try to be very active there, very, please ask all your questions there. That is the core part of Kafka. So Neelam is asking, will we will be doing hands-on in the classes apart from theory? Yes, I will be showing the hands-on, the Java APIs. I'll be showing it, and wherever required, I'll be running the code and I'll be showing it. So even like to make the concepts clear, right? So I have taken some extra effort to create some extra program which was not really included in your course, but I have just done with, just to show you how it is, what it is. I have even done that, and I'll be showing that as well, so which will make you very clear. Are we doing it parallelly? Not really parallelly, Neelam. That may not work out because we have many participants. If everybody doing it parallelly, and if someone is stuck over there, right? So clearing then going forward may not be possible. So we have actually lot of content to be covered. I feel like some of the module has around 100 slides and all. 100 slides covering a 3 hour is extremely difficult with explanation and question and answer. So again, with that, if you go with the practical hands-on parallelly, may not work out, Neelam. So that's not basically parallelly. If you want to try out, you can try out parallelly. So maybe it'll be difficult for you to concentrate over your parallel. You're trying out something and listening that. Maybe it is like difficult to concentrate both the sides. It's up to you. All right. Any more questions before we actually get into the first module? Okay, so I again repeat, if you have any questions when I explain something, you please post your questions. I may take that question right there, or I may take once I finish explaining that, I'll take it and explain. So don't, I want to make it as interactive as possible. So please ask whatever doubts you have it. All right. So I may be able to answer, I may not be able to answer. That's a different question, but please post your questions. Definitely, I'll come back if I cannot answer right forward, right away. I'll come back on that. Sure. Okay, so looks like no more questions. Let's begin. I hope you're able to see the second slide, that is Apache Kafka certification training. So we are at the first module, that's Introduction to Big Data and Apache Kafka. All right. In today's module, we are going to cover a bit about what is big data is all about, and where exactly Apache Kafka fits in big data. This is what we are going to cover in today's module, right? So basically, a little bit about big data and the introduction to Apache Kafka is what we are going to cover today's module. The entire course has been divided into 10 modules. The first module that we are going to cover today, that's introduction to big data, and introduction to big data, and then big data and Apache Kafka. Then we talk about Apache Kafka producers. So producers as the one of the important component of in Apache Kafka, right? So producers are nothing but the agents or the services which is basically responsible for publishing or sending data into Apache Kafka. So we talk a lot about Apache, the Kafka producers, its internals, how things are working in Kafka, and different types of producer API, Java API for that matter, right? So all those things we'll be covering in this module. And Apache, sorry, Kafka consumer. So similarly, once we have the message in the Apache Kafka, it is the others component which basically start consuming these messages and does the processing, whatever, right? So the basically the consuming part. So we'll be talking completely about Kafka consumer. So these three modules is like the core concept, right? The initial Kafka, right? The core concepts would be covered in these three concepts. So we would be taking close to five sessions to complete this, right? It's close to 5 sessions to complete this, because I'll be spending more time here. If you understand first three modules, right, the rest of the part will be very easy to understand. All right, then we have the fourth module, that's Kafka internals, where we are talking about the internals, internally how things happen, the storage, how basically the complete Kafka system works internally. We would be covering that in the fourth module. And in the fifth module, uh, different types of Kafka clustering architecture, and those who are interested for the administrating Kafka, right, we will also be showing different types of commands available for the administrators. So that is what we will be covering in the fifth module. And sixth module is about how do you monitor Kafka. If you have a Kafka cluster, how do you monitor and make sure that your Kafka cluster is running healthier and there is no issue with it? So what kind of monitoring you should be doing it, and what are the things that you should monitor in Kafka installation? So this we'll be covering in the sixth module, plus Kafka Connect. Kafka Connect is the another important add-on from Kafka in Apache Kafka, where instead of writing your own producers and consumers, you have Kafka connectors available through which you will be able to produce and consume messages. So we'll be covering that in the sixth module. Then in the seventh module, we are talking about stream processing. So you would know what is stream processing is. If not, I like anyway explain that before we go to the seventh module. So Kafka also has come up with its own stream processing engine, stream processing framework. So we'll be covering completely about stream processing in seventh module. Yeah, Kafka streaming itself can be treated as a complete course, right? So we won't be able to completely cover about Kafka streaming there, because yeah, in 3 hours, whatever is possible, I will be covering that. So Kafka streaming is basically a very huge topic, or it can be a course by itself. And in the eighth module, we would be covering about other distributed computing. How does other distributed computing systems like Hadoop, Spark, Storm works with Kafka? This is what we will be covering in the eighth module. And in ninth module, we'll see how do we integrate Kafka with Flume, Cassandra, and Talent. So this is what we would be covering there. And finally, we have a project, Kafka project, which I would be showing in the class itself. And in the entire 10 modules, wherever required, I will also show the practicals. All right, it's not just only theory. I will show practical as well. Yes, some of the modules, if you take more of like theory there, but wherever possible, I'm trying to show you the I will try to show the examples, or practical practical demonstrations wherein you will be able to understand better. All right, so this is how the course has been outlined. And in today's module, we are going to learn about the big data, what is big data, and then we'll get into what is, try to understand what is Kafka, and why it is being used, what are the advantages of it. These are the things we'll be covering, and a bit about how it is working and all. Right? So we are going to start this module. So do you have any questions as of now, or is it clear to everybody? So if you're clear, you can just quickly type clear or I'm good, so that it gives me the confidence, like yeah, you're understanding things. Yeah, Neelam, do not use the window which you use now. That is a personal, no, it's a personal messaging window. Instead, use the question and answer window. All right, Neelam. Yeah, because I won't be paying attention to that window. I always look the question and answer window where I get everyone's message. Yeah, thank you, Bhaskara. Right. So change in structure of data over time. So what change in structure of data over time are we talking about? Let's look at that. Okay, so they're talking about the kind of messages we are processing today has completely changed. If you go back about 20 25 years back or 20 years back, right, the kind of messages or kind of data that we were processing was like, very much structured, right? It was very much structured. So in fact, we have different, like they have classified the data into four different types. We look at that: structured, semi-structured, quasi-structured, and unstructured. So what is trying to say in the previous slide is like change in structure of data over time. About 20 25 years back, right, the kind of messages we were processing was most are like structured. What is the structured data? Structured data is like very well structured, right? Which means, for example, a data which is stored in a database, right? It has a very good structure. Like this is the table name, this is the table name, and each row has these many fields. For example, it has 5 fields, and each of its field has the data type, its length, what is the maximum size it can be. It's very well structured. So processing these kind of data is very easy. So our computer systems were processing more of structured data if you look back, right? But in today's world, it has completely changed. We are actually processing less of structured data. But if you compare with the older data, maybe we are processing more. But today, the reality is like we are processing much more than structured data. The unstructured data we are processing a lot, right? So what are the other one? We have structured data, semi-structured data, quasi-structured data, and unstructured data. So as I told you, structured data, you understand it is well formatted. It has fixed length, fixed size, fixed data type. Everything is like, we know upfront. So dealing with this kind of data would be very easy. And you have semi-structured data. Semi-structured data is like almost it is structured, but cannot be taken for granted. Like, it is as fixed sizes and fields like structure. For example, your JSON objects or your XML, right? It can have some field, or like, some fields may be like repeating. So even though it has a structure, it's not completely structured like a structured data. That's a different types of data we process these days. And then we have quasi structured data. What is a quasi structured data? uh, Quasi structured data is data which is um, which is basically unstructured data, but with the help of tools and softwares, you can process it so that you will be able to convert into a structured data, right? So uh, quasi structured data is basically it is almost unstructured. It is almost unstructured data, but with the help of tools, it can be formatted. It can be formatted. The very good example for this would be a web server logs. So web server log is basically an unstructured data, but with the help of tools, we will be able to process it, and we will be able to extract and make it formatted. All right, that's about quasi structured data. Then it is unstructured data. Okay, so Muhammad Nazim is asking, can you explain the semi-structured data again? Yeah, semi-structured data is like messages like, your JSON object or XML, and these are semi-structured data where it has a structure, but not the granularity like your structured data. So for example, some of the field can be missing, like, it's not a mandatory field. It can be there, it cannot be there in the XML. So such kind of things, right? It is because of this, it is considered as a semi-structured data. So just that it does not have the same level of organization and uh, you know uh, predictability like structured data. XML without XST, not without XST. The entire XML is considered as semi-structured data. Uh, I mean, don't get into that. When yeah, with the XST, we'll be able to parse correctly and things like that. It is just that every data, right? It every data, if you compare, it does not have a fixed structure like the earlier data. Like, yes, you're right. We would be able to have. I mean, semi-structured is similar to. Exactly. Yeah, yeah, that is correct. So Ajay is saying, I mean, semi-structured is similar to XML where it is not consistent. Exactly. So it's not consistent like structured data. That's what it is. Muhammad Nazim, able to relate? Just that the data does not reside in a fixed fields or records. No, but it does contain elements that can separate the data into various hierarchies. All right, yeah, he says yes. Good. So yeah, then comes to unstructured data. Unstructured data is like, everything else, like, these days your social media data available, or your email data, your PDF data, like everything, even your, like, data sent by your mobile, right? It sends a lot of your location wise information, everything, like, yeah, some are semi structured. So there are a lot of unstructured data, or you're extracting some information from some couple of PDF files. So these are considered as a unstructured data. So that is what it's trying to say. Change change in structure of our sorry, change in structure of data over time, right? So we have completely changed the kind of data we were processing it. So in about 20-25 years back, most of the time we are processing like structured or semi-structured data, but in today's world we are processing more of unstructured data, right? So basically unstructured data is exploding. The growth of unstructured data is really, really high. If you look back, yes, years back, unstructured data is like very less now. But today, if you look at the unstructured data, is like really, really the growing really faster than the structured data. And it is considered that by 2020 there will be around 5050 to 100 GB of data for every person in the net. Imagine the amount of data these computer system has to handle, right? When it is structured data, it was easy to handle, it was less in size. But today you have a lot of unstructured data, you're mining data for information from the unstructured data. So it's completely, you will have to have a different technologies too. We have a question. uh, okay, Nazim is asking a question, who is IDC? I remember IDC is the International Data Corporation. All right. So the point here is like we have a lot of data available, lot of unstructured data available. Now we may not be able to use the same system that we were using earlier for the structured data, or where we have a less amount of data. We have to completely use big data technologies so that we are able to process this data, and on time we are able to process and get some valuable information out of it. All right. So what is big data? So according to you, what is big data? Can all of you put just one liner, or yeah, just what is your understanding about big data? I want all of you participate. So whatever you feel like, what is big data according to you, please put your answer there. So Muhammad Nazim is saying huge data with lots of combination. Okay, so huge data is what he is stressing on. And Bhaskara is saying any structured or unstructured data which is really huge, like TBs. That's right. Neelam is saying 5 V's velocity. Yes, 5 V's. That's what we're coming to, Neelam. And Purish is saying extremely large data set. Absolutely. Huge data that is a single machine cannot handle alone, right? And velocity, Neelam. Yeah. So of Stravan, huge data. Yes. So most of you are talking about huge data, or like, very high amount of data or large data which cannot be handled by a single machine. And this was the, and then Neelam was saying about 5 V's, right? Yes. So it is basically big data is any amount of structured, semi-structured, or unstructured data that has the potential to be mined for information, right? It not just that it is a huge data. We should also see that if you process it, we can extract some valuable information out of it, right? That is when we actually call it as a big data, or we have a huge amount of data, and it can be structured, unstructured, semi-structured, or quasi-structured, whatever, right? And it has some potential data that can be mined from it, right? That's called as a big data. So now here, like, there are various contributors to big data, the exploding big data, and even this, right? So let's explain let's look at what is big data in detail. So as someone was pointing out, I think Neelam was pointing it out, right? 5 V's. So big data is often explained with 5 V's. That is volume. Right? These are the characteristics of your big data. If your data has any of these characteristics, right, it can be considered as a big data. So what is it? One is volume. I think I don't have to explain what is a volume is. It is easy to understand. Yeah, it is easy to understand. One is volume, which means you have your data which is actually very high in size or very high in volume. Then variety, you're dealing with different varieties of data. Not, you're not dealing with a single type of data. You have varying type of data you're dealing with, or different types of data. So that is what variety. If you have volume or variety, your data can be considered as a big data. Then velocity. What is velocity? The rate at which the data is coming for processing, or the data is coming to use, like, very lightning speed, very fast the data is coming. Even then you would need some sort of big data technologies to be used to process it. So when you have a very high volume, when you have different varieties of data to deal with, or when you have a very high velocity is nothing but the rate at which the data is getting generated, or the rate at which the data is coming to you for processing, or for storing, or whatever purpose, right? If it is really alarming rate, right, then it is considered as a big data. Until recent past, it's been considered as 3 V's: volume, variety, and velocity only. In the recent past, not recent past, about 2-3 years back, again two more V's added to it. Those are that made it 5 V's. Those are value on veracity. So value is basically, can this data can be converted so that this adds value to your business. So only if you have no only if you have some data that can be extracted. So does it add value to your business? Just because of you have a very huge amount data, or just because of you have a variety of data, or the data, you're receiving data in, like, in a very high rate, does not mean it is a big data for you. You should also ensure that the data which you're going to process adds value to your business, or adds value to your whatever you're trying to do, right? So does it have the kind of data we are looking for? So that is what the fourth V, value. Does it add value to your business? And the fifth one is veracity. So veracity is uh, basically correctness of the value, right? I'll give you an example. Maybe with this example it is easy to understand, or easy to explain, in fact. uh, some data, what happens, right? You have a huge amount of data, it adds values as well, but some of the data, or portion of the data, may not add value to your business, or may not add value to business. For example, I am doing some kind of analysis with respect to your tweets, right? With the public tweets that is available, the tweet feeds, right? I'm consuming a tweet feeds from a particular geographic location, and I'm doing some analysis, some kind of sentimental analysis I'm doing on that. Let's take an example, a Bangalore city. I want to process tweets that are generated from Bangalore city, right? I want to process or analyze tweets that are generated from Bangalore city, and maybe I'm using this for some kind of a survey, some kind of analysis and all. Now, there is a possibility, like, right, 90-95% of the Twitter data what I receive is actually from Bangalore, or actually from Bangaloreans. When you say Bangaloreans, they are permanent resident of Bangalore, right? There can be another 5% who are actually tweeting from Bangalore. They are not Bangaloreans. They are uh, basically on a short vacation, or on a short business trip, or short family trip for a couple of days. They are also tweeting from Bangalore. Because of that, they actually in this particular geographic location, I have received this. Maybe I don't want that, I want to omit that. So these kind of information, right, when you have some kind of incorrect data, or does it correctness of the value, right? So that is about veracity. So it is like, considered your data is a big data when we have these 5 V's: volume, variety, velocity, value, and veracity. So I hope it is clear to all of you. Any questions here? If it is clear, you can quickly say I'm clear, so that we can spend our time somewhere else where we need more clarity and all. All right, so Purush says it's clear. So okay, so Muhammad Nazim is saying, I don't see the difference between value and veracity. A value as a no as in total, veracity is about some of maybe 95% of data has a value, but it is possible that, like, always that the entire data doesn't give you add value to it, right? So there are some of the records, for example here, right, some of the records are like, I would say anomaly. Like, I would say it is not a correct data. I don't want to consider that data for my analysis. So that is about veracity, portion of it. But here, when you talk about the entire data, does it make sense to, or no? Does it make sense to process the data so that I will be able to extract some value out of it? If it does not add value to me, what is the why should I process it? The entire collectively, does it add value to your business or not? That is the value. Does it add value to business? That is about value, Nazim. Yes, both are like related in a kind. It is related, but yes, one is like, can we talk about in whole? One is talk about Muhammad Nazim. I'm not clear. It is like other cities. No, no. So for okay, for you're asking, is it like other cities tweet? So now, for example, uh, I want to maybe I know it is a uh, an e-commerce site. Like, it's an e-commerce site. So this e-commerce site is deciding, let's process the data available in Facebook or Twitter, right? Let's try to process this data and identify the market trend, right? Identify the market trend so that we will be able to offer the best product or best service what the current market is demanding, right? So in order to do that, right, you should make sure that if I process the Facebook tweets or Twitter tweets, right, I would be able to extract the information which I want to, which I will be able to get to the to get the market trend. So only if it adds value to your business, then it makes sense. Otherwise, just going and processing the data does not make any sense. That's about value. Does it add value? If does it have some potential information inside that so that I can extract, and which adds value to my business? Okay, so Ajay is saying we are actually going very slowly. Can we cannot finish this slides in 3 hours? That's right, but at the sense I've been saying, Ajay, for the first 3 modules, right, I'll be taking more time so that we'll be clear with it. Yes, I'm just taking, yeah, more time here because I had some questions. Yeah, thank you, Ajay, for your suggestion. So now we are into some of the technologies that's been used in the big data. So big data is a challenge because when we have whatever 5 V's you're talking about, then then processing is not as simple as like with processing the single machine. So you would have different uh, sorry, yeah, you would need different kind of technology to be processed, because when you talk about this big data, everything is a challenge. Your processing is a challenge, storing is a challenge, searching is a challenge, and indexing is a challenge. And if I want to keep every data to be staged in a messaging system, even that is a challenge, right? So these are some of the technologies that's been used in the big data industries. Like there's a very few: Apache Spark, Apache Storm, and Spark Emblem, HDFS, Yarn, Hadoop, and HBase, Cassandra. So these are the some of the technologies that has been used in the industry. So we are going to learn about Kafka here. Now, what is big data analytics? Now, what is big data analytics? Let's look at that. So, a big data analytics is like, now we've talked about. Okay, so Ravi is asking, where does Kafka fits in the previous diagram? Okay, so Kafka, right? I talked about distributed processing, where we have a huge amount of data available. Then a single machine may not be able to process it, which means we will have a distributed computing environment where it can process parallelly. Now, now, how does this distributed computing receives this message or gets these messages? So Kafka would be used to stage the messages until it is processed, right? All collected data, all incoming data would be stored or staged in a messaging systems like Kafka, right? Where it can scale up whatever level I want. Right? Anyway, we'll be coming to this, why exactly Kafka have been used, or where exactly Kafka have been used in the following slides. We are covering that. So a short answer is like, to stage the data until it is processed, we can basically stage it in the Kafka. No, these messages are not stored in the HDFS. So whatever this picture we are talking about, it is a collectively the big data technology. So Kafka and HDFS, there is no direct relation as such. So the messages are not stored in HDFS. Kafka has its own storage Ravi. Okay, so this is in the basics. So we'll cover that anyway in the upcoming slides. Yeah, I was talking about big data analytics. So now, what is big data analytics? So it's about, you have the data available now. If it adds value to your business, can you find out some of the hidden patterns or unknown correlation that resides in your data, or will I be able to find some market trends by which I would be able to maximize the revenue for my business? So this is basically big data analytics. I would give you an example. um, so I'll give you an example. For example, um, in a e-commerce in e-commerce website, uh, there is a product X and there is a product Y, right? There are two products, product X and product Y. Now, uh, all customers who is buying the product X, right? All customers who is buying the product X, out of which about 60 percentage or 65 percentage of the people are buying the product Y after 2 weeks, right? They buy product X now, exactly after 2 weeks they buy the product Y, right? About 65 or 70 percentage of the people, which means it's basically there is a correlation, or there is basically a pattern to it, right? So those customers who is buying X are end up buying product Y as well. So if we can find these kind of uh, unknown correlations or unknown patterns, hidden patterns like this, right? Maybe I would be able to maximize my revenue if if I can send out an email maybe exactly after 2 weeks. If I can send out an email, those who have purchased product X, right? So maybe I would be able to reach 90% or 95%. I would be able to sell my product Y. Those who are buying product X are buying, by default they are buying product Y, even though there is no direct relation. Like product is completely different, even though there is a hidden pattern which basically people are buying product X are buying product Y. So if I can find out this kind of unknown, I'm giving an example, unknown correlations like this. If I can send out an email to those people who purchase product X, after 2 weeks I can send out an email about product Y. Maybe I can, in from 65 I can make it to 95 or close to 100. So this kind of thing I would be able to do with the available data, thereby I can maximize my revenue. Other good example would be a recommendation engine. So we have some questions. Yeah, so yeah, that is about, yeah, Muhammad was saying Amazon does this when we purchase. Yeah, that is about recommendation engine, because based on your purchase history, based on the kind of product that you're purchasing, right, you would be getting like recommendations. Like for example, I purchased some baby products today. Maybe I will start receiving messages or emails with respect to the baby product. So that's about the marketing, right? That's about analyzing the existing data and extracting the information available and then converting this into maximize your profit. So that's about big data analytics. Benefit of big data analytics, it's straightforward. um, you would be able to streamline your operations because you have lot of data available. For example, knowing the market trend for a given season, right, for the seasonality or a trend. If you can know upfront, we can basically better plan the future, right? We can better plan for the business operation. So these are some of the benefits of applying big data analytics. And yeah, you would be able to offer better products and services if you can analyze the if you have data available, and you can analyze what kind of data, or what kind of product or services the current market is demanding for. If you can identify that, so you would be able to offer better services and product for your customers, and make smarter decisions, right? And with the help of available data, you would be able to make better decisions. For example, dynamically increasing the price or dynamically decreasing the price based on the trend or based on the demand, right? Based on the demand in a particular city. For the maybe some of the products, it is for a particular city the price is higher, or not even particular city, a particular user the price is higher, just because of the system understands that he is a potential customer, he will anyway buy this. So maybe it will increase the price, or the same time the opposite can also happen, it will decrease the price, because just to ensure that you will end up buying, just to ensure that you will buy this product. So you'll get a some dynamic discount. So this kind of these are some of the examples I'm giving. So basically, with the help of these available data, you would be able to make smarter decisions, and end of the day you're reducing cost and then maximizing the profit. So these are some of the advantages when you apply the correct analytics or correct uh, data analysis. If you do with the data available within your environment, you will be able to maximize your revenue, right? So we have been talking about messaging systems. So we have been talking about big data for the last, I think, last 1 hour. Now let's talk about Apache Kafka, right? What is messaging system? What is Apache Kafka? This is what we are going to cover from now on. So before I go into that, any questions from anyone of you? Okay, so I think very less people are active. Like Ajay is active, Ravi is active, Muhammad Nasim is active, Bhaskar is active. How about others? Shravan, Vibodh, and Neelam, right? Yeah, fine. So let's get started with messaging system. Fine, fine. Thank you, Purish. Thank you, Vibodh. So when you have this amount of data, right? When you have so much data available, so when data has been collected and sending out, right? For example, imagine I'm going to uh, consume data from a Twitter. Twitter will have a huge amount of data, right? Where do I store this data until it is getting processed? So that is basically a challenge. First of all, collecting the data and storing it somewhere until it has been processed is a challenge, right? Collecting and storing until it has been processed is a challenge. And secondly, uh, analyzing these data in the real time is a challenge. If you have this data available and in the real time you need to analyze it, right? So these two things are the biggest challenge you will face when you have a huge amount of data or when you have a high velocity of data to be processed, right? Let's look at how Kafka can help here. So what is the data pipeline? So we'll come to that, how Kafka can help there. So before that, what is the data pipeline? So data pipeline is basically when you have two systems and these two systems are basically communicating, right? So forget about the chat server or database server here. So just think about, you have a system X and you have system Y. You have system X and you have system Y. So these two different applications need to communicate. So they may communicate directly, right? They may communicate directly. So it is simple, right? There is no complication. So they just pass data from system X to Y, and maybe over a period of time, right? Instead of just only being a chat server, right, you will have multiple, like maybe you have a Hadoop front end. So instead of, don't get into the details of what is Hadoop data front end and all. So you say you have system X, you have system A, you have system B, you have system C, and everything is trying to communicate to another system, say Y, right? So you have A, B, C, D, and you have system Y you're communicating with. So this is also fine. But if you have multiple systems like this, there are a lot of communication happening with your system, right? Then things will get complicated, right? Then things will get complicated. So you have a lot of data to be sent from there, or the same kind amount of data what you're sending from your chat server, right? It goes to database server. It also go to security system, right? So then it becomes basically a lot of data moving around, right? The data movement is really huge. So this can be actually fixed by introducing any messaging system, not like only Kafka. Any messaging system you can bring in between this kind of systems, so that it will be little more cleaner and little more easy to handle it, right? So I can basically have a messaging systems. So all these system which is publishing messages, right? Yeah. So publishing messages can publish into a centralized messaging systems, and this system which is interested for this data, right, they would be able to subscribe. For example, uh, this sends a message called A, right? This sends a message called A, right? So this A would be stored here, and there are multiple systems. For example, your database server is interested for this, and your real-time monitoring or like other services is interested for the same message. So it basically can go and subscribe to this message, right? So instead of sending the friend is sending directly A here and directly A here. So that is basically like multiple times I'm publishing the same messages. Instead, I can publish this message to a centralized messaging system, and the applications or the component which are interested for the messages, they can just basically subscribe to this and they would be able to receive it. So basically Kafka will decouple your data pipelines, right? It basically decouples your data pipelines. So Ajay Martil is asking, during the messaging process, does Kafka have memory repository or database, yes, it has its own storage. So the way how things are getting stored, that we would be covering in the fourth module. When we cover the Kafka internals, we will be covering that how the message is getting stored, and what is the, what is it behind, all those things will be stored. And in today itself we'll be covering the how internal structure we would be covering. There is something called as like, partition. So we will be covering partition in today itself. Yes, to answer your question, yes, it has its own storage, but not as a database. It has its own storage. uh, Clear, Ajay? Okay, so basically Kafka, it was Kafka, like any messaging system, if you use it right, it will help you to decouple your systems. Like that is that's a design principle, right? Yes. Now let's look at what is Apache Kafka to offer. So Apache Kafka is a distributed pub/sub messaging system. I hope all of you understand the word distributed. However, the word pub/sub, right, or publish subscribe is being highlighted here. So can anyone of you say what is a pub/sub messaging system? Or I would ask this way, we all understand what is a messaging system, right? So I would ask this way, what's the difference between a pub/sub messaging system and a point-to-point messaging system, right? So the question here is, what is the difference between a pub/sub messaging system and a point-to-point messaging system? We understand that Kafka is a messaging system, right? There are various other messaging systems as well, but what is the difference between a pub/sub and a point-to-point messaging system? Please come back with your answer. Ajay is saying yes. That's right, Ajay. But yeah, that is right, Ajay. But can you answer this? What is the difference between a point-to-point and pub/sub? So that will be more, that will give more clarity to me. That's right, Shravan. Not really, Muhammad Nazim. No, that is what is said is right, but what I was looking for is not exactly the basically I want the difference point-to-point and pub/sub. That's right, Ajay Martin. So sorry, Ajay Mittapalli. Sorry. Okay, I think yeah, we have that. Thank you, Ajay. Uh, pub/sub multiple sources. Ravi. Okay, Ravi is saying pub/sub is the way where the producer publishes a message for any registered subscriber to get it. Absolutely, Ravi. Yeah, that's what I was looking for. And Purush is saying point-to-point sent from one application producer or sender to the another application, another application consumer or receives via queue. Okay. Okay, so the basic difference between point to point, right? When you in point to point, uh, in point to point, you have one publisher or one publisher and one you have one consumer. So whatever message you publish to one publishers, right, the consumer receives it. So if you have other consumers, right, they won't be able to receive. Like one consumer is what they get. I'll just give an example. The basic difference is something like this. Say if you have a messaging system, assume that this is a messaging system. I'm not talking about the Kafka. I'm saying a in general some messaging system, and I have say some agent or some services which is basically a publishing messages. I will say publisher, or like producer, right? In point to point, what happens, right? You have say multiple say consumers. I'll say you have multiple consumers. You have a consumer 1 and consumer 2. I would say consumer 1 and consumer 2. uh, say it is publishing a message. For example, it is publishing a message called hello, right? And now in case of point to point, what happens, this would be either consumed by, this would be either consumed by consumer 1 or consumer 2, right? But not both. But in case of a pub/sub model, what happens is, right, a similar thing. In case of pub/sub model, what happens is, if it is a pub/sub model, what happens is, right, yeah, what happens here is, like, the same message would be able to get multiple consumers. This is basically, they are subscribers, they have subscribed to a particular channel, they're subscribed to a particular topic. So whatever messages comes to that particular topic, all of the consumers get that, right? So that is the basic difference between point to point and pub/sub. All right, so is it clear to all of you, the difference between pub/sub and point to point? I hope this clears. Okay, fine, fine. I think, all of you already understand it. If anybody did not understand, I just wanted to explain it, right? So now you should understand, Kafka is a pub/sub messaging system. So because it is able to give you pub/sub mechanism, pub/sub model, it is also point to point, right? All messaging system which is pub/sub are also point to point, right? So it is a pub/sub messaging system, and it is a distributed. Why do we say it is distributed? Kafka is a messaging system which is distributed. So which means I would be forming a cluster of Kafka, right? So which basically means, when I say Kafka, my Kafka is installed, it doesn't really mean I'm installed Kafka in one particular box. So assume that this is one machine, and this is another machine, right? And this is another machine. So I have a cluster. I'll be forming a cluster. This is a Kafka cluster. This is a Kafka cluster. With a, I would say this is a 3-node cluster, because I have 3 machines, right? I have 3 machines. So this is a cluster. So this is a machine 1, machine 2, machine 3. 3 different IP address, 3 different hardware altogether. And my Kafka would be installed in all the 3, and whatever topic or whatever queue I create, that is getting distributed. It does not get stored in one place, it is getting distributed. That's what we mean by Kafka is a distributed pub/sub messaging system. All right, so it was originally created in LinkedIn, and it is fast, scalable, durable. We'll come to this one by one. We'll be discussing this, right? So for the time being, understand Kafka is a distributed pub/sub messaging system. This is an overview how people use Kafka. So you have your uh, some of the publishers or messaging, or producers, which sends data to the Kafka, and you have different consumers. It could be a stream processor, it could be some Java services, or any other services which basically interested for this, right, would be subscribed to one particular topic, right? Every message that you publish from the producer, you will also say that it should go to one particular topic or one particular queue name. So you will also say this message I'm publishing to the one particular queue name. So now the subscribers or consumers who has subscribed to a particular queue name, they would start receiving these messages, right? So there can be different types of consumers. There can be Java service or stream processing, anything, right? So this is an overview how typically how Kafka is being used. Now let's understand the features of Kafka. Right? Let's try to understand the features of Kafka. High throughput. Kafka is a system which is able to give you high throughput. What is basically throughput? Can anyone tell me what is the throughput? Yeah, that's right, Bhaskar. Throughput is performance. Yes, yes, it is actually talking about performance. So throughput is basically a measure, right? Throughput is basically a measure by which I would be able to say what is the inflow or outflow of my system. For example, for example, I would say I have created one Java services, right? I've created Java services, and someone is asking me, what is the rate at which it will be able to process, or what is the throughput it is able to process. So I would say it is able to process a 1,000 messages per second, which means my Java services, whatever I've written, right, it is receiving some message from some server, and it is able to up to 100 messages per second it is able to process. So basically, throughput is a measure by which we would be able to say the uh, amount of time or amount of the number of messages that it can process in a given period of time. So usually we say, like, per second, like, 1,000 messages per second or 100 messages per second. So the amount it is able to process in a given period of time. Exactly. So we're saying the rate at which the data can be processed. So that this is basically the throughput. So it is a Kafka is a system which is able to give you high throughput, which means I would be able to send that data to Kafka in a very high rate, like very high rate. I will be able to send data. This is one of the key feature of Kafka, or this is a one feature because of which Kafka is so popular and people are really using it. Because in big data industry, what you would need is the high throughput. Your messaging system should be able to cop up with the throughput what you are sending. Suppose you have a lot of producers, lot of publishers. It is sending data in very alarming speed, right? Very alarming speed. Now, if your system, a Kafka system, is not able to receive the same rate, right, then it's a problem. So that is the right problem what Kafka is able to solve here, where other systems are not able to solve, right? Other ActiveMQ, RabbitMQ, ActiveMQ, RabbitMQ is also scalable, but beyond a point, you won't be able to scale up the throughput, right? But Kafka is able to do that. We'll look at how and all. We'll look at later. And because of it is high throughput, scalability is not an issue. And and in and scalability is also, which means dynamically I will be able to scale. For example, today I have a 3 node Kafka cluster, right? 3 node Kafka cluster, which is giving me around, say, uh, just for example, it is giving me 50,000 messages per second, right? I'm able to process, or I'm able to receive, my Kafka system is able to receive 50,000 messages per second, right? Now, maybe I have requirement in the next month. I'm targeting, or I may have about 75,000 messages per second. So, which means I should be able to scale up as and when needed. So now scalability is also easy in Kafka, which means I don't have to bring my server down. Dynamically, I will be able to scale up. Right? That's very very important. Dynamically, I will be able to scale up my system without even bringing my system time, which means with no downtime I will be able to scale up. So I have today 3 machines, 3 node cluster. I would be able to add fourth and fifth system, um, without bringing my existing cluster down, right? Dynamically I would be able to add. So scalability is also not an issue, not an issue. As in when I need, right, I will be able to scalable. So I would also say it is linearly scalable, right? Scalability not an issue, but I would also say it is linearly scalable. I think, most of us, when we evaluate a new solution or new framework, where we look at, is it scalable, or we also look at, is it linearly scalable? So can any one of you say what is the difference between scalability and linear scalability? Both are basically, almost same, but what is the difference between scalability and linear scalability? I am saying Kafka is a system which is linearly scalable. Okay, so Ravi is saying rate at three. Ravi is saying, Bhaskar is saying scalable by adding similar system to cluster. That's right. Rather than making the same machine powerful. No, that you're trying to say the difference between horizontal scalability and and vertical scalability. I'm not talking about horizontal scalability and vertical scalability. I'm asking scalability versus linear scalability. Bhaskar is saying more system we add, more output we get. That is scalability. So linear scalability is also that with one little difference. Okay, I'll just explain that. So linear scalability is basically you would be able to predict the your system. For example, okay, let me take the same example here. Say you have a system. This is scalability. Okay, this is scalability. I have a one machine added. So now my cluster is able to give me, right, my cluster is able to give me about 25k messages per second. 25k messages per second. Now again I wanted little more, maybe I wanted like on 30, 35 or something. So I again add one more system. I add one more system. So now it is able to give me, instead of 25, I am able to get somewhere about 45k messages per second, right? So my requirement was about 35, so 45k I have. So now later I have again a requirement of somewhere about 60,000. So I again add one more. I again add one more to my system. So which I'm able to give now, which I'm able to give instead of 45, I'm able to get around 63k messages per second. So this is called scalability. I'm able to scale up by adding more systems. Ravi is asking, and without need to change any code. Yes, I mean that will come to that later. If I'm talking about a system cluster wise, I'm talking about, yes, actually without need to change any code, we don't have to really change anything, right? So for the time being, don't get into the code part of it now. We'll come to that later. You will be understanding that later anyway. So this is about scalability. Now let's talk about linear scalability, right? In case of linear scalability, what happens, right? So I have my first system, I have my cluster, and initially I'm adding one system, right? So I have about 25k messages, 25k messages. So again, I had a requirement where I need to increase my throughput, right? Then I add one more system. Now it becomes, instead of 25, right? Since it is linearly scalable as a function, as a linear function, my system is able to give you right away 50, right? Later again I want to add one more system, so this will give me 75, because as a linear function I would be able to say with one system I'm able to achieve 25k, with three system I will be able to achieve 75k. So there is, it's completely, everything is parallel, because of which it is completely as a linear function I would be able to predict what would be the system would be able to give me with three node. Knowing what is the system throughput it can give with one single node, it will be, I will be able to predict what it can give you with with three nodes. So this is basically as a linear function, right? I can calculate, but here it is not a linear function, it is scalable but not linearly. The As in when you add, right, you don't get the same kind of performance. Initially when I add, it is 25,000. When I add a second one, ideally it should have been for 50,000, but I was getting only 45 because there is some other design bottlenecks, because of which it is not linearly scalable, but it is scalable. Does it give you the complete difference? What is the difference between linear scalability and scalability? So I'm saying Kafka is a linear scalable model. Okay, I think we have one more joinee, Prabodh Reddy. Prabodh Reddy, am I audible to you? I don't know, when did you join? I hope you're following the session. Prabodh Reddy, am I audible to you? Sorry, come again. This is my upgraded one. What does it mean? All right. Okay. Fine. Fine. Prabodh Reddy. Fine. Thank you. Okay. So I hope everybody is following it. Everybody is understanding it. Now, the next point here is data loss, right? So Kafka is a system which can ensure you zero data loss if you're configured properly, right? So Kafka system which will guarantee you a zero data loss if you have configured properly. So we'll come to that like and all. So time being, high throughput, scalability, and data loss. Next is stream processing. So Kafka is basically used in the stream processing systems. I don't know how many of you have know about string processing frameworks like Apache Spark, Storm, Apache Flink, or Heron, or Google Dataflow, and things like this, right? So these are the distributed computing frameworks. So these kind of distributed computing frameworks heavily depends on systems like Kafka, right? So it's Kafka and this distributed computing frameworks works very well, right? It's a very good combination and works very well. In fact, some of the distributed computing frameworks are depends no are their feature is basically depends on the Kafka's features, right? With Kafka and the distributed computing, they claim that we can give you this feature or this one of functionality. So Kafka with distributed computing works very well. So we both is asking what is the difference between Kafka and Storm in terms of streaming. So I understand your question is with respect to the stream processing, right? So Kafka is also in the recent past they have had streaming libraries. So your question is how is that different from Storm stream processing is what I'm assuming your question is. Uh, in case of Storm, what happens, right? You need to have a cluster. You need to have a cluster ready, and the cluster and you would be uploading your job and it will be running in the cluster. But whereas in case of Kafka, you don't need to have a distributed computing cluster. In case of Kafka streaming, you don't have to have. So you will be starting your service as any of the Java service and it will be running. And Kafka streaming uses topics, right? Internally, everything would be happening in the topic. So basically, this we can cover it when we get into the Kafka streams. So when we talk about Kafka streams, maybe we can talk about that. So maybe for others, right, this question may not be able to relate. So we'll take it this when we actually discuss about Kafka streams. We both in detail, yeah, we can discuss over there. And then durability. So Kafka also provides durability. Whatever message we publish into Kafka it's not only keeps in its memory, it also keeps or it physically into the physical disk. So Kafka do writes its message into the underlying file system, so that messages which are published are durable, right? Messages that are published are durable. So durability is also ensured by Kafka. Then replication. So Kafka also gives you replication. So the messages that you're publishing, right, which basically means the messages, for example, this is your Kafka system, right? This is your Kafka system, your Kafka cluster. say let's have a 2 node Kafka cluster or 3 node Kafka cluster. Let's take a 2 node Kafka cluster. So now the message that you are publishing, for example, right, somebody is publishing a message A, somebody is publishing a message A here. So this message is actually getting replicated to other systems as well. The message is actually getting replicated other system as well, which basically guarantee you fault tolerance. If at all this particular node in the cluster is down, right, if at all this particular node in the cluster is crashed or it is down, still the message is available in other systems. So there is no single point of failure in case of Kafka. It is completely distributed. The data is getting distributed, plus the data is getting replicated. Thereby, even in case of failure by this system, right, one of the node in the cluster, your message is still safe. The consumers would be able to consume the message from the replication, right? So Kafka also giving replication. We'll come to in detail. We'll be covering how it is and all. For the time being, we should understand it is a system which is able to give you high throughput, scalability, minimal no data loss, and it is a good uh, it works well with stream processing systems, and it also gives you durability and replication. Okay, so Muhammad Nazim is asking how long the message will be saved on the disk by default. It is by default the message will be saved by 7 days. You can configure that. There is a policy, there is a retention policy which you can configure. Using which you would be able to configure this, and you can override this. So Shravan is asking actual message will be stored in the big data storage like Hadoop. Shravan, no. Kafka Kafka is a Kafka itself is a big data solution. So it has its own storage. It has its own data files and storage place. So it will be storing there, right? So it has nothing to do with any other system. It has Kafka has nothing to do with Hadoop. Kafka has nothing to do with MapReduce. Kafka has nothing to do with your Apache Storm, Spark, and all. Kafka can work independently, but yes, Apache Storm, Spark, and all will consume messages from Kafka to process the messages. So it has nothing to do with Hadoop. So it has its own storage uh, system, Shravan. Okay, so Mohammed is asking, do we have any kind of primary and secondary node in case of replication? We have, Mohammed. I will be covering that in details. A short answer to your question is yes. There is a primary and secondary. It's not called primary and secondary. It's called leader and follower. We will come to that, Mohammed Nazir. Prabhat Reddy is asking, is maximum duration of retention messages 7 days? Not maximum. The default is 7 days. The default is 7 days. However, you can configure this. You can increase it whatever days or whatever hours you want. You can configure that. So the default was 7. I think the question was what is the default? So I said it's a 7. Fine. Okay. So let's move forward. Comparison between Kafka and other messaging systems. So here, this particular graph trying to attribute the difference between a Kafka system and in any other messaging system. So the comparison here we have Kafka. So forget about Kafka batch 50 and batch 1. We are yet to learn about it. For time being, understand Kafka, there is a batching as well, right? So we are comparing ActiveMQ, Kafka batch 50, Kafka with batch 1, and RabbitMQ. And similarly, so this left diagram, right, this is with respect to the producer. When a producer or a publisher is publishing messages, how does the Kafka perform, right? So if you look at, right, active mq is like, somewhere bottom, right? It's completely bottom. So it is the throughput what which is offering is the lowest. If you like RabbitMQ, the purple color, right, the purple color, so it is somewhere in the just above the ActiveMQ, right? RabbitMQ just above the blue line. You can see the RabbitMQ. That is also not able to give you the kind of throughput which we are looking for. right? And here on top of that, we have Kafka with batch 1, and you're able to see it is little more better. But with Kafka batch 50, right, you're actually able to get a very high throughput, about like close to 450 messages per second, close to 450 messages per second. This is basically a comparison between producers. When you publish message to Kafka, how is the throughput with in three different messaging systems, right? Kafka, ActiveMQ, and RabbitMQ. This is basically a comparison. So you can see it's clearly Kafka is a winner. Clearly, Kafka is a winner. In fact, you cannot really compare Kafka with ActiveMQ. Does not make sense at all, right? ActiveMQ uh, you know, cannot give you this kind of uh, throughput what Kafka is able to offer. And this diagram is basically when a consumer is consuming from the Kafka, or when a consumer is consuming from other system like ActiveMQ or RabbitMQ, right? So how does it? So here also the Kafka is a clear winner. So if you look at here, the blue line is again ActiveMQ, the purple line is again the RabbitMQ, and Kafka is again the winner here. So in fact, this throughput, right, you will be able to again increase it based on the cluster size. Based on the cluster size, we would be still able to increase this. And here as well, the consumer also, I will be able to increase it based on my cluster size. So we'll come to that little later, like how exactly we would be able to increase my throughput and all. And the Kafka growth, like people have started using Kafka in the recent past, right? The growth has been really, really good, and uh, all almost all companies which are working with working in the big data space are using Kafka, right? So these are some of the. So Ravi is asking, is this comparison with single broker or not? No, it is with a multiple broker or not, Ravi. Whatever you're able, it's giving 500,000 messages or not. It is with a multiple broker or not. Mohammed is asking, I would like you to talk about linked. Okay, so he's saying, I would like to talk about the LinkedIn issue and how did they solve using Kafka and why it is named Kafka. Okay, so I don't know really the reason behind why it is named Kafka. I have no idea about that. Can answer later. Okay, I will come back. Like we'll discuss this. Okay. Yeah, fine. So now we are going to learn about the concepts. Like in Kafka, we have been learning about what is Kafka, the features, what is big data, and all. Now we are going to learn about the Kafka concepts. Like building blocks of Kafka. We'll be covering what is partition, what is topic, and what is producer, what is consumer, things like that. So before that, we'll take a short break for 5 minutes. All right. So again, we'll come back after 5 minutes. So I think it's almost 1.5 hours we started. So we'll take a short break now, and then we'll come back. Is that fine? All right. So all of you, please come back on after 5 minutes. So 5 minutes, Bhaskar, 5 minutes. Maximum 5 minutes. We'll again rejoin after 5 minutes. All right. Yeah, I'm back here. I hope all of you are back from the break. Okay, thank you, Muhammad. How about others? Everybody is there, right? Shall we start? Shall we continue? We both yes, thank you. Purush also says yes. Okay, I think most of you are there. Yeah, Ajay says yes, fine. So I think we have one more new Shiva Rao. I think Shiva Rao you just joined, I guess. Shiva Rao, I don't know when you joined. Looks like you were not there in the initial, right? Initially when we started. I hope you're following it. Do you have any questions, Shiva Rao? All right, thank you. Thank you, Shiva Rao. So in case if any questions, you can please ask me, or if you missed the initial portion of it, right? You and I think Prabodh Reddy, both, if you want, you can go through the recordings. Recordings would be available ideally after 3 4 hours. You can go back and listen to it. All right, fine. So now we are actually getting into Kafka concepts. So these are some of the terminologies that's used in Kafka. That is producer, consumer, partition, broker, topic, and zookeeper. Let's look at one by one. I think producer and consumer is easy to understand, right? Producer and consumer, these are the two concepts which are very easy to understand. Producer is the one who basically publishes or sends messages to a Kafka system, right? Sends messages to a Kafka systems, because we don't know what is a topic yet. So I'm saying it is a producer is a one, or is an agent. It can be anything. So let me just draw it. It will be very easy to relate and understand. So I'll say, suppose I have a Kafka system here. Assume that this is my Kafka system. I'm just writing it here. So this is my Kafka system or Kafka cluster. So I'll just say Kafka system or Kafka, and say this is my producer, right? We call it as a with the name producer. In fact, I can have no multiple producers. I can have producer one, producer two. There can be multiple producers which is publishing messages. So I'll say producer so one, producer two, and so on. So these producers are the one who basically publishes or sends data into Kafka. So I can have n number of producers. It's not like one. I can have one to n number of producers as per my need or as per my uh, the requirement. Like what kind of throughput I want to achieve, or what kind of messages I'm receiving from different places. Like accordingly, I may have n number of producers. So producers are the one who basically publishes or sends message to Kafka. So we know about producers, and we'll be talking in detail about producers in the second module. And then we have consumers. So consumers also same like producers. They are basically consuming message from your Kafka system. They are the consumers from the Kafka system. So similarly, I can have n number of consumers like producer. And consumer one and consumer two. So they are the one who basically consumes message from your Kafka. So these are very clear. I know this is, in fact, you will already know. There's nothing difficult to understand. Broker partition, I will not explain now. Let me talk about topic. So whenever a producer or consumer, right, deal with your Kafka, it is also say like I want to consume from a different topic. Topic is nothing but a queue. Like in any messaging system, you have a queue name, right? So there will be multiple queues existing. I can have n number of queues or topic. In case of Kafka, we don't use the terminology queue name. Instead, we use the terminology topic. right? We use a terminology called topic, right? So whenever a producer is producing a message, you will say that I want to produce a message to so and so topic. For example, I can say I'm producing a message to a topic called say invoice data. My topic name is invoice data, which means I would be creating a topic with a name. Say here inside this, right? I would be creating a topic with the invoice data. So that is one queue, or that is one topic. Whenever you produce a message, you will say that I want to publish a message to so and so topic, so that this will be producing message to a topic called invoice data. And whenever consumer is consuming, right, it will again say that I want to consume from a one particular topic. So it could be like, this producer is also producing the same topic, this consumer is also consuming from the same topic, right? It can be, or it is also like, I have another topic also, like, I also have something like, my what do you say user data, some user data, or something different. Now I can have another producer which basically publishes to this topic, and I have another consumer which basically consumes to a consumes from this. So topic is basically a grouping of messages. So the same way how we have queue, right? Similarly, it's basically bundles, or basically a logical boundary for your data, right? So whenever you produce and whenever you publish, you always say that I want to produce a message to one particular topic, right? So you know about topic. So we covered producer, consumer, and topic. Now broker. What is a broker? So broker we already talked about when we talk about a Kafka cluster, right? A Kafka cluster can be of any size. It can be a 3 node cluster, or 3 broker cluster, a 4 broker cluster. So we have a 4 broker cluster. So when you say a broker, right, that's a single. Okay, we have a question. So he's asking, Neelam is asking a question: can one producer produce two topics? Yes, a one producer can produce two topics as well, right? So producer is basically it's a service, a Java, right, Java code, or yeah, basically whichever API you are familiar with, and you will be producing messages to them. So you can basically switch also. You can produce two different topics as well. All right. So yeah, I was explaining about broker. So broker is, so these are called brokers. So I can call it as this is a broker one. I can call it as this is basically broker one, and say this is broker two, and each broker will have a unique ID also in the cluster, right? Each broker which is joining the cluster will have a unique ID. So broker is nothing but one of the node which is part of your cluster, right? This is a broker. So this is basically a broker. So if you have multiple brokers, that forms a cluster. So we also know broker. So these are different machines. For example, this would be IP of this machine would be 192 160, sorry, 192, say 168, 168, say 1.13, right? This is one IP. So this will have a different IP altogether. So this will be 192, 168, 1 dot say 70. So similarly, this will have again different IP. So these are different machines or different boxes in which I have installed a Kafka broker, right? A Kafka broker. We will use like a Kafka node, or Kafka broker, which basically means one and the same. So that's what I've just explained, Mohammed. So I may use broker or node, it's one and the same. We use a broker, we use a terminology broker that is quite familiar that is quite, people use the word terminology broker in the messaging system world. That's why it's called as a broker. So we will keep using broker or node. Basically, both are one and the same. Since we are talking about the messaging system, right? So we are calling we are using the name broker. That's all it is. So we know producer, we know consumer, we know broker, right? And we know topic. So now let's talk about partitions. Or before partitions, let me talk about zookeeper, right? Zookeeper. So since we are forming a cluster, so the coordination between these cluster, right? Because this all for broker together is my cluster. So my Kafka is a 4 node cluster or 4 broker cluster. This all collectively is my cluster. Now of course they among themselves, right, there should be some kind of communication happening so that it forms a cluster, and some kind of coordination has to happen. So the way how the coordination happens, or the coordination agent, is zookeeper, right? There is a something, an external component called zookeeper, an external component called zookeeper. So all of these brokers are would be communicating a central point called zookeeper as well, right? A central point called zookeeper as well. So this is basically a coordinating place. So we will look at in detail in future, like, what kind of informations are getting stored here. So these things we would be covering in the fourth module, right? Fourth or fifth module, we'll be covering that. So what kind of information are getting stored here, and why is it required? So these kind of information in detail we'll cover uh, in the upcoming modules. Now for the time being, you understand zookeeper is the one who basically does the coordination work, or this is a place where the or the common information or common object about the cluster is stored here, right? That's a zookeeper. The zookeeper is not zookeeper is an independent component. Zookeeper is again an Apache project, so we are using, or Kafka is actually dependent on zookeeper. So one of the prerequisite for Kafka is zookeeper, right? So zookeeper is the only prerequisite for Kafka, zookeeper and Java. So Purish is asking, can one consumer subscribe different topics for different producers? For different producers. So come again. I'm not clear with what is the question. Purush, I'm going to unmute you. So I'm going to unmute you, Purush. So please ask your question.
I'm basically asking, like, one consumer, like, can he subscribe to two different topics from two different producers?
Okay, so yes, one consumer can subscribe from two different topics as well, irrespective of whether it's been produced by a single producer or different producers, because consumers are not directly dependent on the producer. They are only talking with the consumer. They're least bothered about who was the producer. So to answer your question, yes, a consumer can consume from two different topics as well.
Thank you.
Okay. Yes. So we have a question from Bhaskar Rao. How far Zookeeper will manage the brokers? How far Zookeeper will manage the brokers or communication? How far the sorry, Bhaskar, I'm going to unmute you. Yeah, Bhaskar. Yeah, I'm the only reason I'm unmuting everybody just to make it interactive. Okay, Bhaskar, please ask your question. I've just unmuted you.
Hi. Just want to know, like,
Can
what
you be a little
exactly
more
the
louder? Can you be a little more
um,
louder, or
sure.
at least closer to your mic?
Yeah, I'm trying. So what's exactly the zookeeper role here? I know it managing this cluster, but is it even managing the brokers or just the communication between them for the different?
No, no, no. It is even managing the brokers. For example, I'll give you. We will discuss in detail later. I'll give you a simple example. For example, right, one of the broker, we initially started a cluster with 4 node, right? Initially started with the
Mhm.
cluster with 4 node. For example, this is failed, or this is not functioning as expected. There is a failure here. Now, the zookeeper is the one who will first identify that, and accordingly, all other brokers also will identify that this particular broker is not functioning, right?
Okay.
So this kind of information, this kind of coordination work would be done by zookeeper, or all common data would be written into zookeeper so that others will be able to understand that yes, these are the things happening in the cluster right now.
Okay.
Correct.
Okay.
So in detail we'll discuss that. So for the time being, it's coordination agent, it's a coordination place, or common objects would be written in the zookeeper.
Okay. Okay. Got it.
Okay, yeah, right. Thank you, Bhaskar. So Muhammad is asking, is Zookeeper dedicated for Kafka, and is Zookeeper is an internal tool? Okay, so Zookeeper is an open source project, It is not only for only for Kafka. Zookeeper has been used in multiple places. For example, Apache Storm uses Zookeeper because they also have a cluster. So as a coordination agent in Apache Storm also has a Zookeeper. And if you look at Apache Flink, the technology which I work, right? We all with that technology also, that Flink also required Zookeeper in order to achieve high availability, right? In order to achieve high availability, even that. So Zookeeper has basically been used wherever you use a cluster, right? It's been used widely. All right, as a coordination agent, it is used. Yeah, fine. So now the last concept we are yet to cover is partition. Now we know about what is a topic. Now a partition is about a topic is actually divided into multiple partitions, right? A topic is actually divided into multiple partitions. So in order to explain this, right, I will basically have done another slide. So this basically will help you to understand more, right? So I'm just showing that. So this is some slides which I've created to explain this, right? So yeah, 1 second. All right, so let's assume that we are we are creating a topic. So I'm going to explain what is a partition. So assume that we are creating a topic with 3 partitions. So basically, partition is something, right? It is your topic is divided into multiple partitions. So when you create a topic, you will also be saying that what is the number of partition you want, right? So whenever you create a topic, you will also say that what is a partition count. So partition is nothing but a topic is divided into multiple partitions, right? A topic is divided into multiple partitions. So let's look at, so here we are taking an example where I am creating a topic called my first topic. When while creating the topic, I have said that I want 3 partitions. So this is what a topic will look like, right? So we will have a topic. This is what a picture which is coming to your mind, right? When you say I have a topic, you will have something like this. The topic name is my first topic, and yes, it is basically we are talking about a queue, or we are talking about a queue, right? Or we are talking about a first in first out sort of order. So this is the kind of picture that you will have in your mind. All right. So now let's get into it. Let's zoom into the topic and let's understand. Since we asked for 3 partition, each of sorry any every topic what we create, right, will be divided into so many partitions, something like this. So if you look at a topic is like this, but internally it would be something like this. Clear? It will be something like this. And each partition would have a partition ID. So in this example we have we have partition 0. This is a partition 0. This is partition 1. This is partition 2. So I repeat, a topic is divided into 3 partitions. And the number 3 came because while creating the topic, I said I want 3 partition, because of which internally the topic is divided into 3 partitions, and this is how it looked like. So each partition has a partition ID: partition 0, partition 1, and partition 2. All right, and it has an order also. Each partition has an order also. It has something called as log data structure. How many of you know what is a log data structure? Those who have worked in in relational database and all, you would have come across like commit logs and all. So commit log is exactly the it's a log data structure basically. Any idea what is a log data structure? It is not log, log, log data structure. Any idea what is it? Okay, so I think no answer. Yeah, that's right, Prabhu Reddy. But my question was, what is a log data structure? Okay, so log data structure is a data structure which is append only data structure, right? You will only append. You cannot insert something in between, right? So log data structure is a data structure which is only append. For example, you have some data. For example, you have some data here. Say some data. For example, so you have say one, and you have something like four here, right? Sorry, it's very big. So you have some data like one here. So you have some data one here. You have say some four here, right? You have three here. So you keep appending towards the end. You can only add something in the end only. You cannot go and insert something in between. You cannot go and insert something here, right? Once written is written. So this, because of this behavior, it is called as a append only data structure. So log is a log data structure, append only data structure. So what I'm trying to say is like each of these partitions are log data structure because you can only append towards the end. So you can relate, right? Queue also, what happens in queue also, you can only add things towards the end, and something will get something will be removed from the top, right? If you know the how a queue works, right? It's a first in first out data structure, right? So similarly here we're not talking about first in first out, you're talking about it's a log data structure where things are getting added towards the end. So each of these partitions are append only data structure, and it also has it also has yeah okay, so yeah, so we are adding a producer here. We are adding a producer to my topic. So typically we'll have a producer which is publishing message to my topic. So if you have a producer, it will be something like this, right? It will be something like this. Now now okay, so before sending a message, I think I need to explain about offsets as well. So let me just take another slide and where I explain the offsets. Yeah, let me just explain the offset. So what I was explaining is like we had a cluster like this, right? We had a cluster like this. Let me make it even bigger. We had a cluster like this, and we had a partitions. Okay, so Bhaskar is asking what do you mean by partition here? Yeah, I'm explaining partition here. I'm explaining partition here. So say assume that we are creating a three broker or three node cluster, right? We are creating a three node cluster, and I'm creating a topic called my first topic with partition as three. Say Bhaskar, when you say partition is nothing but your topic is divided into multiple partitions. So I'm going to explain what is a partition here. So these are the broker, right? This is a broker. I'll say this is broker one, this is broker two, and this is broker three, right? So I'm creating a topic called my first topic. I'm creating a topic called my say my first topic, right? Topic. So while creating the topic, I would have also said like my partition count is three, which means a topic would be divided into three. So internally, each of this broker would be having a something like this. Internally, each of this broker would be having three partitions, right? So which means my topic is divided into partitions. So for better understanding, right, I would give it different colors as well. So let me just put some lines also, because we are talking about a messaging systems where each data basically would be stored in a corresponding field, right? So these are the basic thing you should understand very clearly. So if you have any doubt, please ask me. I will explain multiple times if you're not clear. So what we are seeing now is I'm creating a topic with three partitions, because of which my topic is actually getting divided, and I have three partitions, three different brokers. To have a better understanding, I will also give a different colors to it. I'll give it different colors to it. Say this has a red. I'll give a blue to this, and I'll give say green to this. All right. So Bhaskar was asking three in each broker or one partition per broker. So the how the partition gets assigned, that we'll get it, we'll cover it, like there is a strategy for that. We'll cover that in later. The time being, you understand, partitions are distributed in the available brokers. Partitions are distributed in the available brokers. Okay, so there's a strategy also for that, but I don't want to get into that now because it'll be confusing a lot. So the time we understand, it is distributed across the available brokers. So now we have three brokers. I'm creating a three partition topic. So my partition is getting distributed. Now each partition would also have a partition ID. So ideally it will be partition 0, right? Let me take black. Ideally it would be partition 0, and partition 1, and partition 2. So please remember, the broker 1 is a one machine, broker 2 is a different machine, broker 3 is a different machine. Maybe if you have a confusion, I will also do, I just put my IP address also here so that you'll be understanding. So this will be 192.168, say 10.15. This is like 192.168 10 dot say 18, and this is 192.168 10 dot say 16, something different. Okay, so this three different brokers, I've created a topic in my cluster. Now this topic is distributed, right? The topic, you can see the topic is distributed into multiple brokers with partition. So the topic is divided as partition, and it is stored, or it is located in different brokers. And each partition is a append only data structure, and it also has a offset ID. So this would be having a offset 0. Each of it has, right, a offset ID 0, 1, 2, 3, 4, and so on. So there is a offset ID also for each of the partition. So inside the partition, there is a each of the message what you publish, right, it will have an offset. I would put it that way. So inside a partition, the message would be stored inside a partition, right? Producers are publishing message to a topic, but the message which you're publishing to a topic would be actually stored in a partition, and each partition has a offset ID. Similarly, this will also start from 0. This will also start from 0, 1, 0, 1, 2, 3, 4, 5, 6, and so on. Similarly, this will also have a starting from 0, 1, 2, 3, 4, 5, and so on, right? So this is what a partition is. A topic is basically divided into multiple partitions, and these partitions are distributed across the available brokers, and which basically means my a single topic is not in a one broker, rather it is distributed across multiple brokers. And the each partition has a partition ID that is starting from partition 0, partition 1, and partition 2, and each of the partition has a offset. The messages which is stored, right, it will be having corresponding offset as well. Any confusion, any one of you? Ajay, Bhaskar, Mohammed, Neelam, Prabodh Reddy, Purush, Ravi, Shivarao, Shravan, and we both. Any questions? Okay, so Ajay is saying no question, no, it's clear. Shravan says clear, no question, nothing specific, but now it's how it gets divided is Bhaskar is asking. Okay, which is the topic here? Okay, I'm good. Okay, fine. So two questions, one from Shivarao, which is the topic here. Another question is from Bhaskar Rao, nothing specific, but now, but how it's gets divided. So your question is like, okay, I'm just going to unmute you, Bhaskar Rao. Bhaskar Rao, yeah. So your question is how the message is getting divided is the question, or how the topic is getting divided into partition. Which is the question? What is the question? I've just unmuted you.
No, I think the partitions we define as three partitions, right? There's nothing logical about it. It's divided
Correct.
into three. But I'm talking about, you said that messages will be divided, right?
Yeah, yeah,
To
yeah,
each
yeah.
part. I was
Yeah, we're
talking
yet
about
to,
that.
yeah, we're yet to cover that. I've not covered
Okay.
this, so I want to
Okay.
make this clear, this thing clear. Then I will cover to that. I'll come to that. All right. So this is clear, right? I'll come to that anyway. Don't worry about it.
Sure. Thank you.
Okay. So another question is which is the topic here? So Shiva was asking which is the topic here. Shiva, I'm just unmuting you. Shiva, yeah. So you were asking which is topic here. So I said the topic. Shiva, can you speak? Looks like you're self-muted yourself. Please unmute yourself. It is showing me that you're self-muted yourself. It is still showing it is self-muted. I just try to click that no unmute button. Okay, he's saying that he's not able to unmute himself. Okay, some issues, probably rejoin might fix it. Okay, that's fine. So his question was which is the topic here, which is the topic here. So I said the topic was my first topic. We created a topic here, my first topic, and that topic is internally divided into three partition: partition 0, partition 1, and partition 2. So collectively these three partition will give us a topic. Collectively this partition will give us a topic, and these are the log data structure. It has a offsets, right? Now let's come back here, let's come back here. Now, yeah, we were here, right? We were here, right? So this is exactly what we were discussing. I have a we have a log data structure. So we have the same partition. We have three partitions: partition 0, partition 1, and partition 2, and it is basically divided into three partitions, and each has an offset as well. Now let's see, we have a producer, right? We have assume that we have two producers, right? We have two producers. Now these producers, when they are producing a message, they are producing to a specific topic. They will say, I want to publish to a topic called my first topic. That is our name. That's the name of a topic, right? Name of a topic is my first topic. So the producer will say that, yes, I want to produce a message to a topic called my first topic. So let's see how what happens in this case. Right now, producer one is sending a message. Producer one is sending a message called A. Right? Producer one is sending a message called A. So it is randomly it went to partition 0. There is no guarantee that it will go to partition 0. It could have gone to partition 1 or partition 2 also. In this example, in this whatever I'm demoing, right, for some reason it went to partition 0. So there is no guarantee that it will always land in partition 0, right? So the message is there in the partition. Now producer 1 is again sending another message, say producer B. Let's see where it goes. Okay, so yeah, again it went to partition 1. So that's no guarantee, like just that it happened, it went to partition 0, right? Now producer 2 is sending a message called D, right? Okay, so some reason it went to partition 1. So there is no guarantee. Is it randomly it is picking one partition and it is basically publishing. So the logic here is like, no, producers are randomly publishing data into the available partitions, right? Available partitions. So again, producer 2 is sending a message. So we don't know where it will go. It might go to, yeah, it went to partition 0. So it's completely random. We have no clue where it is going, right? Now again, another message. Producer 2 is sending another, right? So it might go to any partition. Yeah, this time it went to partition 2, right? This time it went to partition 2. Now, because of this design, because of this Kafka's this design, a topic is getting divided into multiple partition. What is the advantage we're getting out of it? Can you think about the advantage? What advantage do we have it with respect to this design? So you should also keep in mind that each of these partitions are located in different brokers, right? So what is the advantage, design advantage we're getting out of this? Absolutely, Prabodh Reddy. Absolutely, Ravi Kumar, Ravi. Absolutely, Muhammad Nazim. Bhaskar Rao, that's right. So I will just randomly I'll pick someone and I'll unmute, and you please explain what is your understanding. For example, I'll pick Prabodh Reddy. Prabodh Reddy, I'm just unmuting you. Can you please explain what you felt as the advantage of this design? You just, yeah, speak now. Now you're unmuted yourself. We are not able to hear you at all. I mean, I'm not. It's not audible to me at least. Prabodh Reddy, are you speaking? Okay, I don't know. It's not audible to us. So I'm just keeping you muted. I'm just picking randomly someone else. Say Mohammed Nazim. I'm just randomly picking someone just to keep it interactive with among ourselves.
Are
Mohammed
you
Nazim.
audible? Are you audible,
Yes,
Arif?
yes, yes,
Yeah.
yes.
So idea behind is when the message goes to different partitions, like it may go to one broker or it may go to another broker. It supports a parallel operation where it can process the messages at the same time. If you get 10 messages, the same message can go to two different partitions and it can process at the same time.
Exactly. So basically, the advantage what we're getting is like a parallel processing, or like I'm able to parallelly process it. Thereby, like my storage getting divided. My operation, this broker can independently store its data. This will have independently be able to store it. So completely parallelized, right? My broker is also parallelizing. It could be something like, right, whatever a broker producer one is going to this partition, producer two is going to this partition. It's completely parallel operation, right? So that is the advantage we are getting out of it. Yeah, thank you, Mohammed. So I just wanted to unmute someone randomly, so that we want to make it like as interactive as possible. All right.
And one more thing, Arif.
Yeah.
Yeah, how is there is a logic like how it goes to another broker, how it goes to one particular partition? Is there any logic behind it?
Yeah, we will come to that. We'll come to that.
Yeah,
So we're in the beginning of it, right? So just want to make sure, like the core concept, where people are clear with it. So we'll come to that. Don't worry about it at all.
yeah.
Okay.
Thanks.
Yeah, fine. So thank you, Nazim. So Shiva is asking, can we use for one broker multiple threads at same time? Can we use for one broker? Uh, can you be a little more clear what exactly, if when you say can we use for one broker multiple threads at same time? I'm not clear with what exactly you're asking. I try to unmute you. Maybe if you can speak. Just unmuted you, Shivarao. It is showing, still showing it is self-muted you. Can you please put your question in a little more detail? I'm not clear with what you're asking, Shiva. So Bhaskar Rao is asking parallel serves read can happen. Exactly, exactly. So Shiva, I'm just waiting for your detailed question. Okay, so same time can we multiple consumers can read it? Yes, it can. So consumers also the parallelism happens. So the moment a producer produces, right? Similarly, a consumers also would be able to consume parallelly. So both both publishing as well as consumption happens parallelly. So that is the main design idea, or what is the main advantage of this, right? So I think all of you understand, right? What is a good thing about okay, so he's asking from one broker. Yes, so from single brokers also, multiple producers as well as multiple consumers would be able to. Okay, I think your question is very specific. Will a single producer would be able to, multiple producers would be able to publish to same, uh, for example, something like this, right? Have producer one, producer two, and both are parallelly producing to a single. Yes, it is possible. Shiva. Similarly, if you have a one consumer, the single consumers also would be able to consume it from a, uh, multiple consumers will not consume from a single partition. That is a different thing. But from a single broker, yes, I think uh, we will learn about all this when we discuss about producers and consumers. So by then you will be little more clear. So we are basically getting into it, like, we're just trying to explain the core concept of it. So for the time being, if you understand this, good. In detail we'll be covering about producers, consumers there. I think the question is if we can have multiple partitions in one node cluster. Yes, we can. So if that is the question, in a single broker, we can have multiple partitions, but you will not really get any advantages of it, provided you don't have multiple disks. So yes, to the short answer is yes, but how benefit it is, that's a different thing that we'll discuss later. Because once you understand, right, you will be able to correlate which is better, which is bad and all. So consumer will consume in same order. Yes, it will, but there is a caveat to it. Will come to that, Shravan. Right. So all of you understand how it is getting divided, how it is being distributed. All right. Now there is a serious problem with this design. Since I am dividing my topic into multiple partitions, there is a serious issue with this. Can anyone point this out? So we have been talking about the advantage of it, and it is it is everybody understand the advantage of it, but there is a serious issue also with this. So what is that? So Shravan is saying if any broker goes down, uh, then yes, that is an issue, but there is a there is a solution for that. Yeah, as an issue you pointed out correctly, but there is a solution for that. I'm not really looking for that for the time being, and because of the design, right, because of the because of the it has been divided into multiple partitions. One important feature is missing here. What an important feature as a messaging system or other messaging system what they offer is completely missing here. Exactly, Ravi. That's what I was basically looking for. So Mohammed Nasim is saying how to make sure the broker do not consume the same message in any partition. No, that has been taken care. So that is where your zookeeper comes to picture. So it's been taken care through zookeeper and all. So don't worry about that. So that can be easily maintained, by the way. But there is something which you cannot do. You cannot do at all. Right? Yeah, Ravi actually could point this out. Just think about, like, which is very, in any queue, you will get this feature, but that is completely lost. We lost that completely because of that, because of this design. Okay, I will make probably unmute Ravi, so you can just explain this to everybody. What is your understanding, Ravi? Yeah, please. Have you just unmuted you?
Hello, can you hear me?
Yeah. Yes. Yes.
Yeah, I think, say for example, if people are placing orders,
Huh.
want to buy items, right?
Huh. Huh.
So the sequence needs to be maintained in that case. Whoever pays the
Correct.
first, he should get the item in the
Correct.
e-commerce one.
Correct. So that is
So with
what I
this
was coming to.
content, yeah,
Yeah, yeah. Thank you, Ravi. Just I'm just unmuting some randomly some people just to make sure everybody's we are active and we are interacting with each other. All right. So thank you, Ravi, for that. So what Ravi is saying is we lost the order, right? We lost the order. Imagine a situation, right? For example, we don't remember, right, in which order, right? We don't remember. For example, let me take this example. Let me take this example. I have a producer. I have a producer here, right? I have basically multiple producers, and each of them are producing messages. For example, this producer message called hello here, right? It produced a message called hello, right? After that, this message produced another message called hi, right? It went to here, it went to here. So we have a message hi, and meantime, this produced another message here, right? This produced another message. This produced another message. Say this message is something say a message called say 123 123, right? And then again this produced one more message called say another number 556, right? Again you had this produce another message to this partition, say say 345. Again your this producer produced another message called uh, good, right? And again this produce another, this producer produced another message called uh, say fine, something like, I'm just giving some messages, say fine. Now when you have a consumer, right, can you get the message in the same order in which it was produced? If you look at the first message we produced was hello, right? The next message what we produced was I think hi, right? Now if at all this consumer is consuming a message, right, if at all this consumer is consuming a message, it might consume from here, or it might consume from broker 2, or it might consume from the broker partition 0 of broker 1. In that case we may not get the same order in which it was produced. So the complete order, right, the sequence is completely lost. I don't get the topic level, right? I don't get topic level order. I don't really know, or I cannot really make sure whether hello was getting produced first, or hi was produced first, or number 56 was produced first. All I know is since within partition, right, within partition there is a ordering. Within partition there is a ordering. All I know is that among these three messages, hello was produced first, and then 123, then 345. And here, all I know is hi was produced first, then I produced good, right? Then I know 56 produced first, and then this was produced. So within an partition, I have a order. I have a strictly ordering, because it's a part. This is basically a append only data structure, because of which I have a order within a partition. But if you combine all the partitions as a topic, I don't really know which is the message produced first, and the ordering is completely lost. Ordering is completely lost. So that is the biggest disadvantage of this. Now you all follow? Did you all follow what I'm trying to explain? Bhaskar, Mohammed, sorry, yeah, I mean, just calling everyone names. Neelam, Prabodh Reddy, Purush, Ravi, Shiva, Shravan, Vibod. Okay, fine. So I'm not getting any answer from all of you. If you have any confusion, please ask me. I'm ready to explain it again. If you have any confusion over there. So Muhammad is asking for a downstream systems how ordering matters. It matters a lot, right? Imagine a scenario, uh, a banking application which uses a messaging system, right? Which uses a messaging systems. Now, I'm just giving an example. Assume that whatever transaction you do with respect to your account, all transaction go through or flows through a messaging system. Now, as of now, your account balance is zero, right? Your account balance is zero, and depositing, you're depositing a 1,000 rupees, and then immediately you're spending 500 rupees. For example, you're depositing, and immediately you're swiping your card somewhere to spend a 500 rupees from this. Now your balance would be initially zero. Then when you deposit, it becomes 1,000. The moment you spend, it becomes 500, right? Now, assume that each of these transactions are following. The first transaction is deposit 1,000. Next transaction is spend 500. If it happens in this order, everything is well and good. You will have your balance 500. Assume that the order changes. The system which is processing this message, right, processes your spending 500 first, right? Even though you deposited 1,000, before it is getting credited to your account, your spending is happening first. Then your balance would be from 0 minus 500, it will go to minus 500. Maybe if you have a overdraft facility, it will go for a minus 500 for a short span of time. Immediately it gets 1,000 rupees credited. Maybe after the spending is processed by system, then your deposit is getting processed. In that way, you might be getting charged for your negative balance. If your bank is actually charging for an overdraft facility which you utilized, you might get charged for a short period of time. Whatever your balance went for a negative balance, you might get charged for it. So here the order is basically matters, right? So it is basically, order is actually important for your downstream systems. Do you agree, Muhammad? Okay, okay, fine. So apart from that, anyone has any confusion here? Is it all clear? What is a partition? So we all started from this slide. So I was going in detail. So this will basically benefits you going forward, right? So we know what is a producer, what is a consumer, we know what is a broker, what is a topic, what is a partition also we know. So topics are broken up into ordered commit logs called partitions, right? So should make sure that within a partition we have order, right? Within a partition, order is strictly maintained, right? There is no confusion over there. But across topic, if you look at, there is no order maintained. That is a one demerit. But we are not really bothered about that. If you actually design your system such a way that the messages that should be processed in order, if we can publish that into the same partition, right? Ideally, I'm getting it, right? I repeat, even though as a topic level ordering is not guaranteed, but most of the time you don't really need topic level ordering. But if you can, for example, the example which I gave, right, for example, a deposit and a spending, right? What if the both deposit and spending, if I can publish into the same partition, so then first my deposit will come, which means my deposit will come here, then my spend will come, right? Spending will come in this order. If I process, there is no issue, because now within a partition it has been, the order is maintained. The only issue is that when this particular data, instead of this, right, instead of this, or instead of this, if you if you keep your this in another partition, for example here, now I don't have any guarantee will deposit will be processed first or spending is processed first. So the idea is like these kind of messages, make sure that it is getting published to the same partition. So how do you ensure that it will go to the same partition? We'll come to that. Did you all follow what I was trying to explain this here? If at all there is a requirement that the messages has to be processed in the same order, make sure that those type of messages are produced to the same partition. Thereby consumers will process in the order, because we have order for a given partition, just that we don't have a ordering for the entire topic level. Did you get that? Did you follow it? I'm expecting more and more questions here. If you're not clear, you can ask me to unmute you. I can unmute you, and I can, you can ask me. Not a problem at all. Yeah. So here, sorry, Muhammad Nasim is asking, is it configurable? It is not configurable, but yeah, there is a logic using which we would be able to ensure that messages are messages of certain type we can publish to the same partition. I'll come to that. So before that, any questions as of now? Is it clear to all of you? If you all of you can quickly say clear, I'll be happy, and I can, without any confusion, I can move forward. If not, you can ask me, you can stop me and ask. Okay, I think it is clear. Okay, so Bhaskar Rao is asking, so I'll just unmute you, Bhaskar Rao. So if it is unmute, right, it will benefiting. Yeah, so can you please ask your question so that let everyone know what is the question?
All I'm saying is,
Can you be a
so
little more louder, Bhaskar? I think it is not that audible to all of us.
how do we ensure the exact order within the partition?
How do we ensure the exact?
Order. That's the solution, right? Basically, we are sending
Yeah,
random.
solution I haven't explained yet. Yeah, solution I will explain it now.
Right. Right.
Solution I haven't explained it. I'm yet to explain that. Okay, I'm
That's
explaining that.
question. Yeah.
Okay, fine, fine. Yeah, fine. Thank you. Okay, so now let's look at yeah, solution. I'll explain it now. So what happens is, yeah, let me come here. All right. So we know, right? These are the messages that is getting randomly produced. So in Kafka, when you produce a message, right? So these are the messages I produce, right? If you see, right, these are the messages I was producing. I was producing a message called A, then I was producing a message called B, then I was producing a message called D, and then I was producing a message called K, right? These are the messages. But in Kafka, I can also produce a key and value, right? A message in Kafka, a message consists of key and value. A message has two parts, right? Now a message has two parts, a key and value. What we have been publishing, right? What we have been publishing here is, it's completely, it is only the message or only the value, right? So in Kafka, I can produce something called as a key as well. So along with each message a producer is producing, I can say this is a key, right? This is the key. So let's look at that. So each log has an offset. We have already know that 0 to 1. Now this producer 2 is sending a message Z. This producer 2 is sending a message Z with a key IND. So I can also associate a key with a message. Now the guarantee here is that whenever you produce a message with a key, right? Whenever you produce a message with a key, all messages with the same key will always land in the same partition. I repeat, when you produce a message without a key, it is randomly goes to any one of the partition. But when you produce a message with a key, the same all messages with the same key always lands in the same partition, irrespective of from which producer also. I repeat, a message without any key randomly goes to some partition. A message with key will always go to same partition, right? With the same key. For example, I am producing a message z with a key called ind. Let's see where it goes, right? Let's see where it goes, right? So since it is producing a message with z, right, while producing it said it will know that to which partition it is going. So it is like it is going to a partition 1, right, the blue partition, because I am producing with the key IND. So it's that whenever I produce a message with the message key as IND, it will always go to the partition 1, right? Remember that IND is going to partition 1. Now I'm producing another message. Message is again same, the value is again same, but the key is Z. Let's see, since because it is Z, right, it is actually going to, okay, the partition 0. Now we learned that for partition uh, message with IND goes to partition 1, message with USA goes to partition 0, right? So let's see message, another message called 12. Now what is the key? The key we are trying to publish for this is with the key IND. Can you all tell me where will it land? Can you all tell me where will it land? That's right, Bhaskar Rao. Is it difficult to understand? I'm not getting any answer. I will repeat if you want. Do you want me to repeat? I just got an answer from Bhaskar Rao. I did not get anything from anyone else. Should I repeat this what I just explained now? Can you please answer? Should I repeat or is it fine? Muhammad Nasim says yes. How about others? Okay, I think I need to repeat this. So multiple people are asking me to repeat. So when we said like, right, whenever we produce a message has two portions, key and value, right? A message has two portions, key and value. When you produce a message without a key, right? Now we are producing a message A, it is only the value, there is no key. There is no key. Key is basically null, or there is no key. So in such cases, the messages are randomly produced to some of the partition. Messages are randomly produced to some of the available partition. That is what we have been seeing, right? We produced a message D and it randomly goes somewhere, right? It randomly goes somewhere. And we're producing a message K, it randomly goes somewhere. And again, we're producing another message, it randomly goes somewhere. So we cannot predict where it goes. But well, now what I'm saying is, when we produce a message with a key, right? A message can has two portions, key and value. Key is not a mandatory. You can omit key. If you don't have a key, it randomly goes to some other partition. You can also produce a message with key. When you produce a message with key, what happens is that message with the same key always goes to same partition. I'll repeat this here so you'll be able to understand a little more, right? So whenever I was producing a message, right, whenever I was producing a message here, say I'm producing message hello, right? So for example, this randomly goes to a partition, right? The message was just hello, right? Hello. So it randomly goes here, hello. Pretty fine, no issues, right? Now if I produce another message, right, another message here, say with a key, with the key called, my key is say something like, I can, in fact I can use anything. I'm using key as the uh, key is Raj, right? Some user ID or something, Raj. The message is hi, right? Message is hi. Now this will go to say some, assume that this is going to this partition, hi. After that, right, after that any producer, after that any producer who is producing a message with the same key, for example, this is producing another message called with the same key, like Raj and hi, say for example, how are you, right? So it's shorting it, say how are you, right? It is producing a message. Now because this Raj is actually a message with the key Raj is, since it is going to partition 1, this will also end up in the partition 1. So the guarantee here is that same same message, right? The message with the same key, not same message with the same key will always land in the same partition. That's what I was trying to explain here. Here we have a message with, I'm sending a message with IND, and it is actually going to partition 1, which means any producer, any message, if it is produces with the message IND, it will always land in the partition 1. So message, another message Z with a different key, right? Here the key is USA, here the key is USA, it went to the partition 0, right? So when I produced a message with IND, it went to partition 1. Here when I produce a message uh, with produced with a message with the USA, it went to partition 0. Now any message I publish with IND will always land in the partition 1. So this is what I was explaining, right? So let's look at what happens. So this is also going to partition 1 because it also has a message IND. So the guarantee here is that messages with the same key will always land in the same partition. So Reddy is asking, how does the first message with the key value know which partition to choose it from? So I will explain that. So we have that towards the end of this module. So at that time I will explain how does it figures out. There is a basically a hashing function. There is basically a hashing function which does that. A short answer is that. So we have towards the end of this module, there is a slide for that. At that time I'll be explaining it. Ready? There is a hashing function for this. That's how we are doing it. So apart from that, others, all of you understand the concept of key value and what is the guarantee we have and all? Okay, so Muhammad is asking, okay, I'll just unmute you, Muhammad. You please put your question.
Uh, my question is like with this approach, with the same key, so one partition will have the more messages. So the huge load will be on the one particular partition, even though other partitions are free. This approach because we will
No,
have.
yeah. So here what happened, right? Here we have what happened, right? See, 1 second. See, here initially we published a message Z with IND, right? With IND. So that went here. So you should be using different keys. You cannot, if you end up using same key, or of course everything will end up in the same partition, does not make sense. You should also make sure that your key is also distributed. Got
Okay,
it? So
got it,
you
got it.
should, you go, so for example, the example what I gave you, for example, what was that? You the bank deposit and withdrawal, right? So for that case you should use your account number as your key, so that since both the operation is happening with respect to this account, it is very much important that the order in which you are processing is important. Does not make
Yeah.
sense, like, you're depositing first, then you're spending it. But whereas there is another user, for example, say Kumar is depositing in between, so that does not care whether should the system process his request immediately after your deposit. That is immaterial, so that can be completely parallel. It is with
Okay.
respect to his account. So you should keep a key, you should identify a key such that your account ID, maybe I can use it, so that my deposit and my spending is or processed in the same order in which I have executed. Clear, Mohammed? Okay, fine. Fine. So is it clear to all of you, the advantage? And this is how I said, you don't, it's not really important that the entire queue should be in the order and entire topic should be in the sequential order. Rather, if you just have the partition in the sequential order, and if you put some logic, right, if you put some logic, the messages that should be processed in the order, if you make sure that your key is you're basically distributing accordingly, then there is no problem. Okay, I think everybody's saying yes. And I hope everybody follows it, everybody understands it, and let's quickly go to next slide. I think by now you would already know this, what I'm trying to explain. So we have a Kafka cluster. There are two brokers. There is a zookeeper as a coordination. You have multiple producers. You have multiple consumers. Producers are producing or publishing message to Kafka, Kafka brokers, and consumers are consuming it. This is the overall architecture. This is the overall, like, overall how a Kafka cluster works with producers, consumers, and zookeeper. I think we have already covered this, so we can basically move forward. Components of Kafka. I think this also we covered. Most of the stuff we have covered. Okay, so Ravi is asking, can a broker have multiple partitions of the same topic? Yes, we can. Ravi, we can have it, but there is a caveat to it. So we would be, you will be understanding as we move forward, right? You will be understanding. Even if I have, yeah, theoretically or technically it is possible, but does it make sense is a different question. So it makes sense as well. So we'll be covering those things little. Once we understand the basics, you'll be able to understand. So yes, good that you are getting confusion or questions like this. That's what basically I want to have, right? Yeah, I think most of the things we already clear now. So however, we'll look at one by one. A topic, I think you don't need to, I don't need to explain this anymore. We already clear about it. Topics are broken into ordered commits logs called partitions. I think by now you're already clear. I've been explaining this. Each message in a partition is assigned a sequential ID called offsets. I've explained that as well. So these were the offsets, right? These were the offset I was talking about. Each partition has an offset, and each message which basically has an offset. Basically I can say the message hello, right, is of partition 0 and offset ID 0, right? Similarly, if I ask you what is the message at partition 1 offset ID 1, what is the message I have in the partition 1 offset ID 1? In my current screen, which is the message I have in the partition 1 and offset ID 1. Uh, Neelam, not really. I'm saying partition 1 offset ID 1. Shivarao and Neelam, please be careful. Offset ID 1. Okay, so I think there is a bit confusion, Neelam. We're going to unmute you, Neelam. Neelam, yeah. That's right, Shiva. That's right. I think all. Yeah, Neelam, I've just unmuted you. Can you speak?
Yeah, I got it. It's HRU.
Correct. Yeah, fine. Thank you. So basically, the way, right, each partition has an offset ID, right? So here maybe little more you cover here, right? So here I have partition 0, partition 1, partition 2, and this is the offset ID 0. This is the offset ID 0, 1, 2, and similarly this will also will have 0, 1, and 2, right? So each partition has its own offset ID starting from 0. That is how a message has been identified in a given partition. That is what is this topic. That is what we just learned, right? Each message in a partition is assigned a sequential ID called partition. So it's a sequential ID and it's called offset starting from 0. Importantly, starting from 0. Each partition has a offset starting from 0. That's important. And each data in a topic is retained for a configurable period of time. I think someone was asking the same question. How long does it keep? By default it keeps for 7 days. So this, when I start installing Kafka, I'll show you the configuration. I'll show you this. So in fact we'll be covering in detail also in the upcoming slides, upcoming modules. So at that time we will cover, so don't worry about it. So there is a configuration which basically controls how long should I keep this message in my topic, right? How long should I keep, because we can't keep it forever, right? The message has to get removed. The message has to get removed. So there is a configurable amount of time. Until then this message would be kept in my topic. So writes to partitions are generally sequential. We already talked about it's a append-only data structure. So whatever data comes to one particular partition, it is in the sequential order. This would be written to a given partition. So forget about this time being. So because this will be difficult to explain right time being. When we talk about consumer, at that time we'll cover this. Reading messages can be either from the beginning and also rewind or skip to a point. The point here is like, when a consumer is consuming, right? When a consumer is consuming, by default it consumes in the same order. So however, if you want to again reprocess, or if you again want to reprocess a one particular message, that is still possible if you know the offset ID. For example, my consumer is consumed from partition 1, it consumed the message 0, again consumed message 1, it consumed 2 as well, again consume 3 as well, again consume 4 as well. But if it feels like again I want to consume the message 2, I can again go back and process this, right? So that is possible in case of Kafka, right? So maybe at this point it might be difficult to understand how and not, but when we talk about consumers in detail, we have this to cover, so don't worry. So the point here is consumers can go reconsume the messages it had already consumed. If required, it can be reconsumed. There is a provision for that. Now now let's talk about here. So instead of explaining there, I'm just explaining this. Now what happens, this is the way how I had messages, right? Let me just put some message here also. For example, I have some messages like 1 2 3 and say good, and I'm fine, or something like some messages I have here, right? I'm fine, I'm something like this. Now my topic is divided into 3 partitions. My 3 partitions are actually placed in 3 different brokers, right? 3 different brokers. It is also possible that I can, while creating the topic, right? When I create a topic, I have to say how many partitions. Similarly, I can also say how many replications. I can also say replication is equal to 2, which mean my partition itself will be replicated. The entire partition itself will be replicated, something like that. So whatever message I have here, right, the entire partition would be replicated to another partition, another broker. Similarly, this also completely would be replicated. So because of this replication, right, because of this replication, so this is again replicated here. And similarly, for example, the partition 2 as well, right? So partition 2 also would be replicated to different brokers. Now what happens, i have a I have a partition 0, I have one copy here, I have another copy here. Similarly, I have partition 1 here, I have one copy here, I have one copy here. Similarly, I have partition 2 in broker 3, I have one copy here, I have one copy somewhere else. So this basically gives you fault tolerance. What is fault tolerance? In case, right, in case I have some issue with my this broker, right, in case if I have in case if I have some issue with, say, one of the broker, for example this broker, I have an issue with this broker and it is not running anymore, whatever message, right, the partition 0 had, it is available in the broker 2. A duplicate copy is available in the broker 2. So this way it is giving you fault tolerance. It is giving you fault tolerance. So Mohammed is asking default how many replication it will have. By default it will have a one replication. When you say replication, right, it is including the original copy, right? If you look at here, I said replication 2, which is including the original copy, right? I have this is the original copy, this is the replication. So put together, I have 2. So similarly, when I say by default 1, it will only have a single copy only. So it will by default it will have only single copy. You need to ensure while creating the replica, when creating the topic, you should ensure that how many partition you should have. Okay, so Bhaskar is asking, how is it available in other broker who sends it? Okay, so let's, before that I need to explain something, some other concept. After that I will explain to you. So basically these are the concepts which we would be explained in the partition, in the uh, would be explained in the next topic. However, I would like to cover it that here itself. Now, each partition, right? This would be called as the leader of a partition, right? The original one, right? The original one, like master slave or something like that, right? Or like uh, take black. So like master slave, this would be this would be called as the leader, and this would be called as the follower, right? Similarly, this would be the leader and this would be the follower, right? This would be the follower. Similarly, this would be the leader and this would be the leader. So at any given point of time, there would be only one leader for the partition, right? For any given point of time, there will be only one leader for the partition. So the producer and consumer always interact with the leader. So whenever a producer is producing a message, right? Whenever this producer is producing a message, a new message, for example, is producing a message called, say, 777, right? So this will not produce a message to this one, the follower partition 0 follower, it will not produce, but rather it will produce to the leader only, right? It will produce to the leader only, right? It will produce the leader only, after which this message would be replicated here, after which the message would be replicated immediately, right? So then you will have it. So producer does not produce message directly to the followers. Producer only produces message to the leader partition, and then the message gets replicated to the corresponding followers. So these are the concepts we would be basically covering in the module 2. So I would want to keep it, I will keep it, I will explain in detail over there, right? As a short answer, I just wanted to cover since Bhaskar was asking it. All right. So Mohammed is asking, will there be a delay in the replication or it will be immediate, and no way there will be a lag? There will be a delay in replication, Mohammed. So all those things are covered in detail in the module 2. So I don't want to get very detailed right now itself, because others may not follow it, right? So we'll keep it for the later modules. Ravi is asking, how does my producer code know where to send messages? I think we'll cover those things when we actually show when I show my APIs. So however, the short answer is, like, whenever a producer, I start my producer, right, it will be having the, you'll be configuring the cluster details. What is the IP of your cluster? What is the port in which your cluster, in your each of the broker running? And we'll also say to which producer you have, which topic you're publishing. There, that is how it will be able to get those information, right? So those things are in detail. We'll be covering them in the module 2 and all. Don't worry about it, right? So Ravi is asking, I mean, how does it know which partition is leader? Okay, so he's asking how does it know in which partition is the leader? Okay, so that is the moment a producer connect to the cluster, it gets the complete snapshot of it, like how many partition it has, and for each partition, who is the current leader? Leader can change any point of time. Who is the current leader? That information would be given to the producer when you first connect to the cluster. Ravi, does that answer your question? Yes, we will be covering that in detail. The short answer is that the producer will get a some metadata about the cluster, metadata about the partitions. So that is how it learns about who is the current partition, current leader. Ravi, are you clear? Okay, okay, fine. So Mohammed is asking, okay, can follower become a leader and leader become a follower? Yes, it can. So during there is a failure, right? It can happen that. So that I will be explaining in detail in the coming modules. So don't worry about that. I think we are going little detail now itself. I don't want that to happen. let's come back to our slide, right? Because let's go as per the slide. So this will definitely help us. So here an example, we have 5 brokers, right? We have 5 brokers, broker 1, broker 2, broker 3, broker 4, and broker 5. And I'm creating a topic which has 4 partitions, right? Which has 4 partitions. So same thing what I've explained here, right? They're trying to explain with a different image, different brokers. In our case we had only 3 partitions, sorry, 3 brokers and 3 partitions. And here you have 5 brokers and 4 partitions, right? So when you create a topic, right, what happens is you will be having partition 0, partition 1, partition 2, partition 3. We know that, right? In our case we had partition 0, partition 1, and partition 2. Here you have partition 0, partition 1, partition 2, and partition 3, because you said I want 4 partitions. And here you have 5 brokers. So it would be kept something like this. The replication would be kept, one replication would be available here, and another application would be available here, and the application would be available here, because you said I want 3 you said replication factor to be 3, right? Replication factor to be 3. So because in total you have 3 replicas, right? In total you have 3 replicas. In our scenario, I said we need 2 replication, right? Because of which this is one replica, this is another replica, and this is a one leader. So this is one leader, this is another replica, this is one leader, another replica. It is same thing here, in a different way they're showing it, right? So each partition, Kafka broker will elect one replica as the leader. We also talked about that. One would be considered as the leader, right? So one would be considered as a leader. So that's it. We'll come in detail. We'll be covering in the later modules. So what you understand is partitions are divided into topics. Sorry, topics are divided into partitions, and one of the partition would be the leader. One of the partition would be the leader. All others would be the followers. Producer and consumer always interact with the leader partition only, right? Leader partition only it interacts with, and the messages are getting replicated from the leader partition to the follower partition. This is what you have to understand for the time being. Okay, so I think for the today we can stop. So we are left with very less, so that is fine. Like, usually right, this much is what I cover in the first module. So any questions, or anyone if you have any questions, because right, I don't want anyone go back with any confusion. What we will continue the session tomorrow. All right, and importantly I want to make one more point very clear here. At end of every session you would be getting a feedback form, right? You would be getting a feedback for the moment you end the session, right? The moment you log out from the session, you would be redirected to a page where you can give the feedback about the instructor and feedback about the course content, and you can also give the rating. You can give the rating in terms of you know the rating you'll be able to to give, and also you'll be able to give some write-up or some feedback about the instructor as well as the course. So I recommend, I appreciate if you can give some time and give the ratings about the course content, as well as about the instructor. Give the rating, as well as if time allows you can also give your feedbacks, right? So please do that. This is very important for me, because the in order to understand how Edureka, in order to understand Edureka, how I'm handling this batch, right? Your feedbacks and ratings are very much important. So please give your feedback and ratings. All right. So you have ratings: excellent, high, excellent, good, average, and bad. So average and bad are considered as negative. Ex Excellent and good are considered as positive. So please give your rating accordingly. All right, so we have a couple of questions. uh, Prabodh Reddy, what would be the Kafka version we are covering in this course? So I am using the version 1.0, right? That's the latest version, the latest stable version available. So I would be using the latest 1.0. So wherever we have, right, 0.8, 0.9 difference and so on, I will be also highlighting this is how it used to happen in 0.8, this is how it used to happen in 0.9. So I'm using the latest version 1.0. Prabodh Reddy. And Muhammad Nazim is asking, I would like you to tell about LinkedIn issues and how did they solve using Kafka. Yeah, I think this we will cover it, because let's understand a little bit about how the design is, then you'll be able to really understand what was the issue, how did they come across that. So before that, let's understand what is Kafka, how it's been designed, like in this partition, the high throughput and all. After that, if you come this way, it'll be easy for me to explain. So let's park it for the time being. We'll take this. If I forget it, you can basically remind me, Muhammad. All right. Ravi is asking, I hope labs are available. Yes, labs are available, and very importantly, keep your virtual machine ready, because from the next class onwards, right, I'll be start showing right from the installation of Kafka, configuration, and how producers are working, how consumers are working. Everything I will be trying to show you. So please have your VM ready. I mean, not you won't be doing parallelly, but yes, once the class is over, right, you should be having your VM ready to practice it. So please have your VM ready, so you can either download the VM that is available from the Edureka, or else you can have your own VM. So I would suggest to have a VM, a fresh vanilla VM you set up yourself. The reason being, you would be knowing completely end to end, because you would be downloading it, you will be installing it. So whatever issues you would have, right, everything you will be facing it. So instead of using Edureka VM, in the Edureka VM, right, everything will be pre-configured. So that may not be, as a good learner, I won't suggest that. Instead, you go with a fresh VM, any VM for that matter. It can be a Ubuntu, or it can be a CentOS or anything, right? You can use anything. I would be using a fresh VM. I won't be using the Eureka VM. I would be using a fresh VM that is available. Nothing is installed in that. Everything is, completely clear. Apart from some pre-required softwares like MySQL, and I have installed in that. Apart from that, I have not installed anything. I will be showing all installation plus configuration in front of you. So, right. So even I also expect you also do it in similar way, so that you will be able to learn much more than working in a pre-configured setup, right? Yeah, so is that clear how we will be having it, how we'll be handling it? But if already are using, yeah, not problem. If you're already using Ubuntu, no worries, you can directly use that. Yeah, even basically I'm also a Ubuntu user. The only reason I use Windows here is like, the the application which we use, right? What is it? This GoToMeeting doesn't work in the Ubuntu. Only as a client you can, as a as an attendee you can able to work. As an organizer, I cannot use Ubuntu client. There is no Ubuntu client. That is the only reason I'm using Windows. Otherwise, I'm also Ubuntu user, right? So yes, if you have Ubuntu, nothing, you can just use it. You don't even need a window then. You don't even need a virtual machine for that. Clear we both? So I want to make the session as interactive as possible. So any questions, any confusion, please ask me. I may be able to clear it or may not be able to. That's a different question. But please ask your questions. How silly it is, how small it is, don't worry about it. Ravi is asking, okay, it's not Gundu, it is Ubuntu, Ravi. It's an operating system. Ubuntu is an operating system. It is Ubuntu. Ubuntu. So Ubuntu is an operating system. It's a Linux. It's a Debian based operating system. So Muhammad Nazim is saying class was good, very informative. Thank you, Mohammed. Please do write your reviews and your ratings accordingly. So don't worry that we are not covered, we have not finished the first module. Don't worry about that at all. We will be completely covering it. I want to spend more time for the module 1, 2, 3 because these are the core concept basics you should understand clearly. Without understanding this, does not make sense. So please, no, I will take more time explaining this. Don't worry that about at all, right? Yeah, so Bhaskar is also saying bye. Thank you, Bhaskar. Yeah, I think we can end our session today. So we'll continue from here tomorrow from this Kafka component messages. We'll continue from here. So Purush is saying you're doing excellent. Thank you. Thank you, Purush. Thanks a lot. No problem, Ravi. So Ravi was saying apologies. I heard Ubuntu differently. No problem, Ravi. Yes, Shravan, thank you. Have a nice day. Shravan, okay, thank you all. I think there is no more questions. So I'm really happy. I know I enjoyed teaching you a lot of good questions. In fact, a lot of good advanced questions you are asking. I myself was stopping, like we'll cover it later, right? Yes, good that you are asking a lot of advanced questions. I really enjoyed it. I really liked the batch. So we'll again meet tomorrow, same time, right? Till then, bye. Those who are going to bed, good night. Those for others, I'm wishing you a good day, right? So I'm going to disconnect. I'm going to sign out from you. I again remind you, please give your rating and your valuable um, feedback at the end of the session, both about instructor as well as the course content. Thank you. Yeah, so I'm going to sign out. Goodbye. Goodbye for today. All right.